Hello guys and welcome to today's session. Today we are going to talk about SCEP certificate delivery via Microsoft Cloud PKI. So this has been one of those topics onto which I've been wanting to do a nugget since very long, ever since we had announced Cloud PKI as a part of Intune suite. So this is what we are going to have in today's agenda. First, we are going to do the very basics and very quickly I'm going to talk about what are certificates, why do we need it, advantages of having certificate, what is the difference between SCEP and PKCS. Then I'll talk about Intune Suite and its components and introduce you guys to Cloud PKI. I'll also do a comparison between Cloud PKI and NDES via which we could traditionally deploy certificates using our on-premise infrastructure. Then we'll do a comparison between Cloud PKI and an on-premise NDES server and compare all the components in both of them. Then we'll track the logs as far as deployment of a SCEP certificate is concerned to a device via Cloud PKI. We will see how we can view those certificates at the device end. We'll then take a look over the Cloud PKI architecture and understand what are the various ways or methodologies within Cloud PKI that can be used. We'll set it up. We'll talk about auditing and reporting. And then we'll talk a little bit about EKUs and understand why they are important. Along the way, I'll be giving you some pointers as well. Then we'll do a live demo wherein we'll set up everything from scratch and see how a certificate is delivered successfully. And then after the device gets the certificate, we are going to understand what are the things that we need to keep in mind and what are the configurations that are needed to be done so that the end device can actually utilize this certificate and present it to the, let's say, Wi-Fi server or VPN server. So we'll talk about all these and more, and this is going to be a jam-packed session. So now let's get started. Okay, so very basic. Let's first talk about what are certificates and why do we need it. So we know that for any user to access any application, he has to go to through phases. First is authentication phase and second is authorization phase. For example, let's say that tomorrow you want to access Outlook. So what are the steps you need to follow to access Outlook, to access your emails via Outlook? After you have downloaded Outlook, you are going to enter your username and password. Now that phase is called authentication phase, where users authenticity is checked. Now after you have entered your username and password, and if it is correct, once the authentication is done, then there is something called authorization. Now the best example of the authorization phase is using something like conditional access, wherein even though your authentication is correct, even though your username and password is correct, conditional access is going to evaluate some conditions and then authorize you to access that application or unauthorize you. Let's say that it will conditional access might require your device to be compliant to an MDM or to Intune, or let's say conditional access will impose a MFA or something like that. So hence there are two phases. One is the authentication phase wherein we enter the user credentials, and one is the authorization phase. Now, conventionally, to achieve the authentication phase, we enter the username and password, right? So let's say you have to access Outlook. What you will do, you will enter your username and password. Similarly, let's say you want to connect to, let's say, Wi-Fi or VPN. What you will do, you will enter your username and password and then you will get yourself authenticated. Now that is one way of getting yourself authenticated. But then entering a username and password has its own disadvantages. And therefore, to make the authentication phase more seamless, we introduce the concept of using certificates. And what is a certificate going to do? Now we are talking about a client certificate. A client certificate is used for facilitating the authentication phase. Now certificates are the best phishing resistant credentials, and they can be used to improve the security. We already know the advantages of using a certificate over username and password, right? Username and password has to be entered manually. Certificates are picked up automatically. Username and password, you might enter it incorrectly, right? Certificates, it will always be correct, right? Username and password, they are prone to, let's say, leakage. certificates cannot be leaked. So hence we already know the using a certificate for authentication has the below benefits, like it is seamless, automated authentication, removes the overhead for user to enter the username and password manually, and it is more secured because passwords are prone to leakage. So this is a background of what certificates are, and the fact that we are using a client certificate during the authentication phase, and the advantages of certificate, why exactly are we using it, and why is it better than using username and password. Okay, so what we spoke about right now is client certificate. What is a client certificate? A client certificate is a certificate which is issued to a client. That client can be a user or a device, and that client certificate is going to help the client prove its authenticity. It's going to help it go through the authentication phase, and it is a replacement of going through, let's say, conventional authentication methodology like entering username and password. Now, there are other kinds of certificates as well. There is something called trusted root certificate. Now, what is a trusted root certificate? A trusted root certificate is a self-signed certificate, and it is in the topmost of the tree. So we will talk about a certificate chain later on, but the way it works is at the top we have something called the root CA. So let's call this the root. And below the root we will have a hierarchy. So below root we can have something called a intermediate. And below the intermediate we might have something called issuing. So this is a three-tier hierarchy, wherein the first tier is the root, the second tier is the intermediate, and the third tier is the issuing, right? So a root certificate is a certificate that is issued by the root and to the root. A intermediate certificate is a certificate which is issued by the root to the intermediate, and a issuing certificate, and then like this server has a intermediate certificate, this server will also have one. So let me just show you an example. So this is the MMC this is the MMC store of this device. Now when I go to the trusted certificate authorities and render certificate, you can see that these are all the trusted root certificates which are installed in this device. Now, if I, let's say, double click and open a certificate, you see that this certificate is issued by DigiCert, and it is issued to DigiCert, meaning it is self-signed, meaning the issuer and the person who has issued it and the person to whom the certificate has been issued to, both are the same. So over here you can see all the trusted root certificates which are present in this device. Now, why is a trusted root certificate important? The trusted root certificate is important for chain building. What do I mean by that? What I mean by that is, let's take a step back. What is a issuing or a leaf certificate? A issuing or a leaf certificate is a certificate which is issued by the issuing CA. So this is, let's say, the issuing CA. This was the root, this was the intermediate, this is the issuing. So this issuing CA is going to issue a certificate. Now, when you look at that certificate, it will have a lot of parameters. One of the parameters will be issued to, and the other parameter will be issued by. So the issued by of this leaf certificate, we are talking about this certificate, the client certificate or the leaf certificate, or which is going to be our SCEP certificate. The issued by for this certificate is going to be this issuing CA, because this issuing CA is issuing that certificate. And the issued to is going to be the UPN of the user, or the device ID, right? If it is issued to a device. Now, why will anybody trust this certificate? If anybody looks at this certificate, it sees that the certificate is issued by this issuing CA, but nobody knows who this issuing CA is. Therefore, we need to install the root certificate in our store, so that whenever we are looking at this issuing CA, it is going to lead to the root. Therefore, we need this. I'm not going to go into very details of what a certificate chain is, because that, as we have already seen in our agenda, I already have chain building and two-way trust at the end after demo. So which we'll talk about in detail. But for now, just know that these are the various kinds of certificates. Um, Client authentication certificate is what we are specifically focused on right now. There is something called server certificates as well. You would have probably seen that in as a SSL certificate when you're trying to access any HTTPS website. There is a certificate that is binded to that website, right? Like for example, right now I'm at google.com. If I click over here and over here, if I click on connection is secure, it is going to show me a certificate over here. If I click on this certificate, it tells me that the common name is this and the issuer is this and all this information. So this is a SSL certificate which has been bound to the website https google.com, right? So now we know what a server certificate is. Now we know what a intermediate certificate is, what a root certificate is, and what a client certificate is. Now we are going to focus on a client certificate. Again, a client certificate is a certificate which the client is going to use to prove its authenticity and to go through the authentication phase. This is replacement for entering the authentication phase manually by entering the username and password. Now, this client certificate that we are talking about, they can be mainly of two types. There is something called SCEP or Simple Certificate Enrollment Protocol, or there is something called PKCS. Right now, we are going to talk about SCEP. Now, as I said, SCEP stands for Simple Certificate Enrollment Protocol. It's a protocol which was originally developed by Cisco. It's based on request and response model like GET and POST. The advantage of using SCEP certificate is that the private key is not marked as exportable, meaning the private key of so a certificate has a public key and a private key, right? But the private key in case of a SCEP certificate is not marked as exportable, which makes the SCEP certificate more secured as compared to a PKCS certificate, in which case the private key is marked as exportable. And a SCEP certificate can be used to a user or to a device or to a userless device. And over here, this point says that the private key never leaves the device, which makes the SCEP certificate more secured as compared to PKCS. Quickly going to do a comparison between SCEP and PKCS. PKCS and SCEP both can be deployed via Intune. Both can be used for doing a seamless authentication to Wi-Fi or VPN. And the main point that we have to keep in mind over here is PKCS is less secured because the private key is marked as exportable in case of PKCS. SCEP is more secured because the private key is not marked as exportable and it never leaves the device. Using PKCS is simpler because I have done a dedicated nugget on PKCS. You may want to check that out. But in case of PKCS, you don't need a lot of components. All you need is a server wherein you are going to install a connector, and that connector is going to talk with the CA and it's going to do everything on your behalf. However, deploying a SCEP certificate traditionally is difficult because you have to set up an NDES server and IIS and app proxy, Intune connector and all of that. Again, I have done a dedicated deep dive on SCEP and NDES. You may want to check that out. So this is what the comparison is talking about. PKCS is less complex to set up. SCEP is more complex to set up. The device only talks with the Intune service and Intune service which acts as a mediator. In case of SCEP, the device talks to NDES via app proxy. We'll talk about all of this in detail later on. PKCS can be load balanced, but it is not very seamless. SCEP can be load balanced, it is more seamless. Again, we'll talk about load balancing later on. But I just wanted to touch base quickly on difference between SCEP and PKCS so that we know that when we are talking about client authentication certificate, we have two options. SCEP and PKCS, SCEP being better, but it has more moving components and has more overhead. Okay, now when we are talking about SCEP certificates, before we deep dive into it, I wanted to take a moment and talk about what is Intune Suite and what is Cloud PKI. So, um, until 2023, let's say until the year 2023, getting a Intune license was pretty much straightforward. all you had to do was either get a Intune standalone license or an Intune A Direct license, or you could get a EMS E3 or E5 suite, which would contain the Intune license. Now things have changed a little. Now we have released two more licensing models for Intune called Intune Plan 2 and Intune Suite. So think of it this way. Think of this box as everything that you can do from Intune. Now, what we do is every month we release a new version of Intune wherein we do a service release, wherein we add more and more features into this bucket. So the end user don't have to do anything because this is a software as a service. So the upgrade is done by the by Microsoft. They do it at the back end. Now we keep on adding features into this Intune bucket. Now, what we have done is we identified 5 or 6 features which were not exactly related to Intune, but it is something that works very closely with Intune. So, what we did was we released those 5 or 6 features and we did not add them to this bucket, meaning they users have to purchase separate license if they want to make use of these individual features. What are these features? These features are endpoint privilege management, enterprise app management, advanced analytics, remote help, Microsoft Tunnel, Cloud PKI, firmware over the air, and managing specialized devices. So these are these different features. They are related to Intune, but you cannot make use of these features if you just have the Intune license. If you want to make use of these features, you need to get license for Intune Suite. So over here you see Intune Suite. If you get a license for Intune Suite, then you can make use of all these features. Or you can just purchase, let's say that Intune Suite is having, so Intune Suite is priced at around $10 per user per month. Let's say that you don't want to make use of all these 5 features. You only want to make use of Microsoft Cloud PKI. So instead of getting the entire Intune Suite license, you can just get the license for Microsoft Cloud PKI, which I guess is around $2.5 per user per month, right? So which means if you just have Intune license, like Intune standalone or EMS E3 or E5 or A3 or A5, you can make use of everything from Intune, but you cannot make use of these features. If you want to make use of these features, then either you need to get a license for Intune Suite, which is going to contain all these features, or you can just pick one specific feature that you want to make use of, and you can get the license for that one specific feature. Meaning you will need this license, which is the license for Intune, which is Intune standalone or EMS E3 or E5 or A3 or A5. Plus, you will need either a Intune Suite license or the license specifically for the product that you want to make use of. Again, this is all very well documented. I just wanted to call it out because this is the first nugget that I'm doing on a product present in Intune Suite, and I have not spoken about this before. Therefore, I wanted to take a moment and explain this. That for you to make use of Cloud PKI, along with Intune license, you either need the license for Cloud PKI, which needs to be assigned to the user, or you need to take license for the entire Intune suite, which also needs to be assigned to that user. Okay, now that we have done the background, now let's talk about SCEP. Why are we here? We are here to talk about Cloud PKI. What is Cloud PKI going to do? Cloud PKI is going to issue a SCEP certificate to the device. Now, before Cloud PKI was introduced, how did people get the SCEP certificate? They got the SCEP certificate by using something called NDES. What is NDES? Now, I'll just again give you a 1,000 feet overview, a 2 minute breakdown of this. If you want details of NDES, please refer to the detailed tutorial that I've done on it. NDES is nothing but a feature, that a role or a feature you can call it, which is there in the server, which can be installed via server manager. It stands for network device enrollment service. It's a conventional way of deploying or distributing SCEP certificate to devices. So the way it works is, again, I don't want to complicate this too much or go very detail into this diagram, but think of it like, let's say this is the Intune service, this is the device. Now the device needs to get a certificate. Where will it get the certificate from? It will get the certificate from the CA. Now the device is there in the internet, and the NDES server and the CA are there in the intranet, right? So the device in the internet cannot directly reach out to the NDES server, or cannot directly reach out to the NDES or the CA, right? So what happens is the device first reaches out to something called app proxy. The app proxy forwards that request to the NDES server. The NDES server reaches out to the CA. The CA issues the certificate and sends it back to the NDES, and then the NDES server deploys that certificate back to the device. So again, a 1,000 feet overview of how a certificate delivery happens when an on-premise NDES is present. Don't get into the details of what is a CRP and what is a plugin and what are all these things, because that is not relevant related to Cloud PKI. But I wanted to take a couple of minutes and let you know, before you know Cloud PKI, you need to know how things worked without Cloud PKI. And that is what I'm showing you guys right now. Don't look too deep into the steps. Just know that there is a device, the device needs a certificate, that certificate is going to come from CA. The device cannot directly reach out to the CA because the device is in the internet and the CA is in the intranet, hence they go via app proxy and they get the certificate. So again, a 1,000 feet overview of how things work in the NDES world. What you need to see over here is what are the components that you have. You have the CA, you have the NDES, you have the app proxy, you have the Intune service, and you have the device. So you have got so many components which you need to set up, install, and maintain in order for the device to get that certificate. Now, just FYI, I have done a deep dive on this topic. You can find it in my YouTube channel. The nugget number is 37. Wherein I've spoken in detail about how this on-premise NDES works and how the certificates to that are issued. Okay, now that being the backdrop, now let's talk about Cloud PKI. So in case of Cloud PKI, our end goal is the same, which is there is a device, the device needs to get a certificate, the device is going to use this certificate to achieve the authentication phase. It's going to be a SCEP certificate, the certificate will be issued by a CA. But it is called Cloud PKI. Why is it called Cloud PKI? We are going to understand that now. So Microsoft announced Cloud PKI as an offering in August 2023, and it became GA'd in March 2024 for everybody to use. And we already know this point that traditionally, if you wanted to issue certificates, you had this as an option, wherein you would need to have an NDES server and an app proxy via which you would push the certificates. So traditionally, admins had an option of doing this via an on-premise NDES server, which was cumbersome to set up and troubleshoot, because you can see there were so many components, right? And there were logs at each and every location. There were logs at the device end, there were IIS logs, NDES plugin logs, CRP logs, and then NDES event viewer logs, and then certification authority logs, app proxy logs. Each and every component had its own logs. So it was a little difficult to track that. So hence Cloud PKI to the rescue. So using Cloud PKI, organizations can simplify their certificate management with minimal effort, because in case of Cloud PKI, we do not need so many components. So the 5 components that we have seen over here, we don't need so many components with Cloud PKI. So the overhead of managing and maintaining an on-premise CA is removed and reduced, because Cloud PKI is going to issue the certificate. So think of it this way. In this case, the admin had to manage this NDES server, had to manage this CA, and everything inside of this CA and everything inside of this NDES server, like the IIS plugin and everything like this, and the CRP and the Azure App Proxy. Now, what we have done is we have come up with a new offering called Microsoft Intune, not Microsoft Intune. We have come up with a new offering called Microsoft Cloud PKI, wherein everything that you see inside the red circle is now removed. And that is now lifted and shifted inside of Intune or inside of Azure. So the customer no longer needs to have everything that is there inside of this red bubble that you see over here. The device will still be there, but all these components will no longer be there at the customer's infrastructure, meaning the customer no longer has to have a on-premise CA or the NDES, or he does not have to maintain the database, or he does not have to um, patch them, or he does not have to update them. So there are so many advantages which come with that. Right? So the overhead of managing and maintaining the on-premise CA is now removed or reduced using the SaaS-based certification registration authority. As the service is hosted in Azure, it's highly available and we don't have to worry about load balancing it. Okay, now let's compare Microsoft Cloud PKI, which is the new offering, with the on-premise NDES solution that we have seen in this diagram. So how is this diagram, that is on-premise NDES, comparing with the Cloud PKI? So in case of manageability, on-premise NDES was difficult to manage because we had to set up an NDES server, and in the NDES server we had to set up the IIS, and then we had to set up the CA hierarchy as well, the PKI, which involved the issuing CA, the root CA. We also had to set up the app proxy, may that be Azure app proxy or any kind of proxy, and then we had to set up the Intune connector. In case of Microsoft Cloud PKI, the management is easy because we don't have to set up anything at all. Because as I said, all the setup that we were doing, which is inside this red circle, all of that is now moved to the cloud. Therefore, we don't have to set up anything and we don't have to manage anything. Deployment, the deployment of on-premise NDES was difficult because we had to set up all these things. The deployment of Microsoft Cloud PKI is very easy. It's very straightforward. It's just next, next, finish. Load balancing, in case of on-premise NDES, if you wanted to load balance your NDES, then what you would have to do, you would have to have multiple NDES instances. Meaning, like over here, you have only one NDES server, right? Let's say that you want to have an instance wherein if this NDES server goes down, the certificate still should be issued. In that case, you would have multiple NDES. Again, I don't want to go into the very details of that, but if I show you my channel over here, I have done a dedicated video on load balancing NDES and SCEP via Intune, wherein I have explained how if you have two NDES servers, how does the certificate issuance works. But just an FYI, in this case, if you want to have load balancing, you would have to set up two different NDES servers, meaning you would have to set up two different app proxies if you want, meaning you would have to maintain all of that. However, load balancing in case of Cloud PKI is very easy because we don't have to worry about load balancing it because Cloud PKI is a SaaS on Azure. So Microsoft is going to take care of managing it and maintaining its load balancing attributes. Supported devices and certificates. Using on-premise NDES, we could issue all kind of certificates to all kind of devices. However, using Cloud PKI, this is important, we can, as of now, issue certificates to Intune managed devices only. So if your device is not managed by Intune, if it is not enrolled to Intune, then currently there is no way of issuing certificates to those devices. And we do not have an option of issuing a SSL certificate. So let's say that you want to issue a certificate which you want to bind to a website. That kind of certificate currently cannot be issued by a Cloud PKI. However, if you had on-premise NDES and on-premise CA, in using on-premise CA, you can get the SSL certificates or SMIME certificates as well. With on-premise NDES, the control was more granular. The control was more granular because in this case you could manage you could specify the certificate template via which the certificate should be issued to the end user and many other things. In case of Cloud PKI, we do not have those selection. The cost is, in case of on-premise NDES, there was no additional licensing cost. The cost involved was only with the setup of that with that extra server. Like you have to set up that extra NDES server, but you can install other things also in that NDES server, which would bring down that cost. However, in case of Cloud PKI, there is an extra cost of $2 per user per month. and troubleshooting the on-premise NDES was a little difficult because there were so many logs of each component. In this case, there is not much of troubleshooting that has to be done or that we can do because everything is logged at the service side, right? Okay, now let's talk about the flow. Let's understand the logs. So until now, we would have understood what Cloud PKI is. So again, let me just paraphrase. Cloud PKI is a Microsoft solution using which we can issue client authentication certificate to end devices, and these end devices can use these client authentication certificate to undergo the authentication phase, that is to authenticate themselves to any service or to authenticate themselves to Wi-Fi or VPN or stuff like that. Now we are going to see now, as we have already discussed, Cloud PKI does not need any on-premise presence, so you do not need to set up anything on the on-premise like any servers or any app proxies or connectors. The certificate is going to be issued from the cloud to the device. Okay, now we are going to take a look over the flow and understand what exactly happens at the background for the certificate to get issued. All right. So in this diagram, we see we have got three components. First is the admin. This is the Intune admin who is going to do all the configuration. The second is the device. This device is enrolled to Intune. And third is this cloud. So in this cloud, this is the Azure cloud. First, we have the Intune service, wherein the Intune tenant is present, the Intune is doing its magic. And then we have something called Cloud PKI. Now we need to remember that Cloud PKI is not a part of Intune. Like as of now, we can only issue, so we can only issue certificates to Intune managed devices, but Cloud PKI is an offering of Azure. Therefore, I have it in a separate box over here. So this is the Intune service. This is the Cloud PKI service. Now inside of Cloud PKI service, I have segregated it into three other components. One is the SCEP service. Second is the SCEP validation service. And the third is the certificate issuing service. Okay. So again, this box is the Cloud PKI, which is the offering of Azure. This box is the Intune service, which is a SaaS on Azure. This complete circle is the Azure cloud. This is the admin. This is the device. Now let's take a look over the steps that are happening. The step number one is that the Intune admin goes to the Intune portal and he creates a profile. He is going to create a SCEP profile and he is going to assign it to a specific user or to a specific device. So this is the very first step that the admin has performed, and he has created the SCEP profile, he has assigned it. Once he does that, once the admin assigns the SCEP profile, there are a couple of things that happen under the hood. The first thing that happens is that Intune service is going to evaluate the effective group membership. Let's say that there is the SCEP profile was assigned to a group called G1. So Intune is now going to evaluate the members of this group and find out who are the members of this group called G1. It is also going to check whether this group, that is G1, has been targeted via a trusted root profile or not. So guys, just an FYI, when you're creating a SCEP profile, you have to link that SCEP profile with a trusted root certificate profile. Now that is a prerequisite. So and one more thing that we need to keep in mind is, let's say that this is the SCEP profile and this is the trusted root profile. We have to make sure that the SCEP profile and the trusted root profile are assigned to the same group. This is very important. Now, what admins usually do is, let's say that there is a user A and the user A needs to have a SCEP profile. Now let's say that the user A is part of two groups, group 1 and group 2. So what the admins will do is they will assign the trusted root profile to group 1 and the SCEP profile to group 2. And then they will say that, well, the user is part of both the groups. So what's the difference? Well, technically you are right. The user is part of both the groups, but a requirement here is that the SCEP profile and the trusted root profile should be assigned to the same group. Okay, so again, a recap, what has been done, the admin has created the profile, he has assigned it to a specific group. Intune is first going to do a effective group evaluation and make sure, and first find out who are the members of this group who are targeted by this profile, and then it is also going to check whether the same group has been targeted via a trusted root certificate profile or not, and whether that profile is successfully delivered to the device or not. So these are the things that has happened in the backend after the admin has created the profile. Okay, now what next? The second thing is, now the Intune service is going to reach out to the SCEP service in the Cloud PKI. The SCEP service is now going to generate, think of it like a OTP, okay, one-time password, which in the terms of NDES and SCEP is referred to something as a challenge password. So the challenge password is nothing but just a OTP. So the SCEP service has generated this OTP and it has sent it to the Intune service. Why has this generated a OTP? We are going to see that later. But for now, in the step 1, the admin created a profile, effective group evaluation was done. It checked whether it checked and found out who were the users or devices targeted by that profile. It found out whether a trusted root certificate is targeted to the same group or not, whether the trusted root certificate is delivered successfully to that device or not. If all of that has happened, then the second step is the device is going to reach out to the Cloud PKI service. And in this Cloud PKI service, it's going to reach out to the SCEP service. And it is going to request for a OTP. The SCEP service is going to generate that OTP and it is going to send it to the Intune service. So that is all has happened until the step 2. The step 3 is that the profile that the admin made, this profile is going to come down to the device. So the SCEP profile which was made by the admin, this profile comes down to the device, and along with that profile, the OTP also comes down. So over here you see there was this OTP. So this OTP also comes down to the device. So the OTP has come down, and the common name of the device and or the common name of the user who has enrolled the device, all that information also comes down. So in the step 3, the device has received the OTP, and I am going to show you guys via the logs in each and every step. First, I want to walk you guys through the flow without complicating it with the logs, and then I will show you guys the logs. So as of now in step 3, what has happened is that the device has received the profile, the device has received the OTP as well, which was generated. Now there is one very important thing that we need to see, and that is this profile, this SCEP profile which was created by the admin over here. It contains a lot of information. Amongst them, there is one very important information that it contains, which is a SCEP URI. Now that SCEP URI is think of it as the address of this SCEP service. So there is this device needs to reach out to the SCEP service, okay, in order to do whatever it is supposed to do next, which is request for a certificate. But this device is there, even though this device is there in the internet, and the SCEP service is also exposed over the internet because it's hosted in the cloud, the device does not know where the SCEP service is. Therefore, in this profile, we have to enter a URL, and that URL points to the SCEP service. So let's recap now. In the step 3, what has happened is the profile which was created has come down to the device. The profile contains a bunch of information which we are going to see later, and amongst all those information is the SCEP URI, which is a URL or an endpoint which is accessible over the internet, and a OTP or a challenge password which was generated by this SCEP service. Okay, now let's see what happens next. Now what happens next is the device now needs to request for a certificate by going to the SCEP service. The device has the URL. So the device is now in step 4 going to go to the SCEP service. But before the device can request for a SCEP certificate, a client authentication certificate, the device has to trust it. The device right now does not trust the SCEP service. The device does not know who this guy is. The device has only got a URL over here, which was a part of the profile, but that the device has no idea whether it should trust the SCEP service or not. So the device does two calls. The first call is called get CA cert and the second call is called get CA caps. We are going to talk about both these calls later on, but for now just know that the device is going to make sure that the SCEP service is actually authentic and can be trusted, and this SCEP service can actually issue a certificate to this device. In order to do that, the device is going to do two calls called get CA cert and get CA caps. Now, what this behavior of this device of doing this get CA cert and get CA caps call, this is a part of SCEP protocol. So when we had on-premise NDES, over there also the device did this. Now in case of cloud PKI also, the device is doing this. So now the device, what has happened is, again, just taking a step back, in step 4, the device picked out the SCEP URL which was present in this profile, and the device made a connection to that URL, and it did a request called get CA cert and get CA caps. In the next step, that is step 5, the device is going to get a response from the SCEP service. The SCEP service is going to respond to the device. What is it going to respond with? We are going to see that later. But for now, just think of it this way. In step 4, the device reached out to the SCEP service and asked a question. And the question was, can I trust you? And in the step 5, the SCEP service reverted back to the device and said, yes, you can trust me because this, whatever the reason or whatever the justification is. I'm going to talk about that justification later on. Okay, in the step 4 and 5, this has happened. Now let me just take a pause over here and let me just uh, talk about all the steps from step 1 to 5 again, very quickly, and then I'm going to show you guys another diagram which is going to talk about step 6 to 10. So I've broken down the flow into 10 steps. For the first 5 steps, we are seeing this diagram. For the next 5 steps, we are going to see a different diagram. Okay, again a quick recap. What was the step 1? The step 1 was admin creates and assigns a SCEP profile. This is the very first step of the flow which needs to be carried out by the admin. Once the SCEP profile has been assigned, the Intune service reaches out to the Azure and identifies the effective applicable users. It fetches the common name. It also evaluates the group association, making sure that the SCEP profile and the trusted profile are linked to the exact same group and not to the nested groups. We have already seen all of this in step 1. Okay, all right. What was the step 2? Now the step 2 is SCEP challenge generation. In this case, the Intune service is now going to reach out to the SCEP service, which is hosted in Cloud PKI, and is going to request for a challenge password. A unique challenge string or a OTP is generated per user per SCEP profile, which is configured in Intune, and the challenge along with the challenge password, the thumbprint of the issuing CA and the timestamp is also sent. So over here in step 2, the Intune service is going to reach out to the SCEP service and request for a challenge or a OTP. In the step 2 response, the SCEP service is going to reach back to the Intune service and generate that challenge or a OTP. Along with that challenge or OTP, it is also going to send the thumbprint of the thumbprint of the server who has issued that challenge and it is also going to tell the timestamp that this is the time at which this OTP has been generated. Why is it sending the timestamp? It is sending the timestamp because this challenge or this OTP has a validity of, let's assume it has a validity of 5 minutes, meaning after 5 minutes this OTP will be no longer in use. Okay. All right. So in step two, we saw that the challenge was generated and that challenge was sent to the Intune service. Now you have a way of generating this challenge manually as well. We could do this in case of on-premise NDES. So if you have an on-premise NDES server, if you go to that NDES server and if you go to the mskep_admin URL, then over there you can see that the challenge is being generated and it looks something like this. Now, in case of Cloud PKI, we don't have an option of generating this challenge manually, but I just wanted to show you guys that in case of on-premise NDES, we had that option, and that is pretty much the same thing which is happening. So the Intune service is going to the SCEP service. The SCEP service pretty much does the same thing, wherein it generates a challenge like this, and over here you can see the thumbprint of the issuing CA certificate, issuing CA as well. All right. So now what is going to happen in step two, we saw that the challenge was generated. In step three, what happens? The Intune service deploys the profile. The profile contains the SCEP service URL and it deploys the OTP or the challenge password. So at this point, this I have taken the screenshot from a device which is enrolled to Intune and which has been targeted by a SCEP profile which is linked with my Cloud PKI. Now I have run the MDM trace tool and I am just using this tool. We can see all the communication that is happening between the device and the Intune service. And over here you can see that the device has received a server URL. And what is that server URL? That server URL is this endpoint. And what is this endpoint? This endpoint is the address of this SCEP service. So when the device got this profile, which was over here, this profile contains this profile that the admin has created over here. When the admin was creating this profile, which we are going to see in the demo, in the profile, he has to provide the SCEP URI. That SCEP URI is the address of this location. So when the device gets this profile, if we look at the logs at the device end, then we can see this URI coming down as well as the OTP coming down. So everything that is coming down from Intune to the device, we can see all of that by looking at the OMADM logs over here. So that is what I was showing over here. So if this is the OMADM logs, I've used the tool by Oliver Kieshelbach, and over here you can see this is the URL. The server URL is over here, and then this is the challenge. This is the encoded challenge or the OTP, as well as these are the other attributes that were there in the SCEP profile, like the subject name to which the SCEP certificate needs to be issued to, which is over here populated with the subject name of the user, which is pm@everythingaboutinTune.com, and then the EKU mapping, as well as the key usage that I have selected as a part of the SCEP profile. So everything that is coming down to the device from the Intune service can be tracked by the OMADM logs over here. And in the OMADM logs, we can clearly see the challenge as well as the SCEP profile coming down, which contains the SCEP service URI. Okay, all right. Now let's see what's next. Now after that is done, the step 4 is over here. Let's go back. The step 4 was the device was reaching out to that SCEP service, and as I said, it's going to do two requests. One is called get CA cert and the other is called get CA caps. Now what are these two requests? The first one is get CA caps, which means the caps stands for capabilities. So the device is getting the capabilities of the CA. Hence the verbiage get CA caps. So right now, what's the end goal? The end goal is the device needs to get a certificate from the cloud PKI. But before the device can request for a certificate, the device wants to know whether the CA can even issue a certificate or not. That is why the device is going to the SCEP service and asking, what are your capabilities? That is, it is getting the capabilities of the CA. The response to the get CA caps is something like this. The device gets a response like this, wherein each of the keywords correspond to the relevant description. Wherein if the CA responds with AES, it means that the CA can issue certificates with AES encryption algorithm. Similarly, if it responds with SHA-1, it means that the CA supports SHA-1 and it can issue certificates with SHA-1 algorithm. If it responds with SHA-512, it means that the CA supports SHA-512 hashing algorithm. That is first. So until now, we have understood what get CA caps is and why is it needed. Get CA caps is a request that the device is sending to the SCEP service, and it is asking the SCEP service, what are your capabilities? Tell me your capabilities so that I know whether you are even capable of issuing a certificate to me with SHA-512 or not. Let's say that SHA-512 is the hash algorithm that is needed by the device, which is mentioned in the SCEP profile. Now, the device does not know whether the CA can issue, whether the cloud PKI can issue a certificate with SHA-512 or not. Therefore, first the device is going to ask whether what are your capabilities. The CA is going to respond with all the capabilities. The device is going to look at it and say, oh, you can issue a certificate with SHA-256. I'm going to need a going to request for a certificate with SHA-256 algorithm. Hence, you can provide me what I actually want. That is what get CA caps means. The response to the get CA caps is a list of CA's capabilities in plain text, which is usually as below. Okay, so if you actually go to that URL, you see this URL that the device received over here. If you actually go to this URL in a browser, you can also find out the capabilities of the Cloud PKI CA. So over here you can see I have gone to that same URL, and this is the response that I got. So this my CA in the Cloud PKI supports AES, it supports SHA-1, SHA-256, SHA-512, and hence my device now knows that the CA is capable of issuing certificates of these parameters. Okay, that is one. That was the get CA caps. Now the second request it does is get CA cert. So currently, the device does not trust the cloud PKI, right? So the device over here, it does not trust the SCEP service. So the device is going to tell the SCEP service, or the SCEP service is eventually cloud PKI, right? So you can say that the device is telling the cloud PKI, okay, you have told me your capabilities. You have responded to get CA caps. Now show me your certificates. Show me your certificates so that I can trust you, and show me your certificates that so that I can use them later on. When is this device going to use that certificate? We are going to talk about that later. But for now, just know that the device after get CA caps is going to do another request called get CA cert. And what does get CA cert means? It means getting the cert of the CA. So the response to the get CA cert is the Cloud PKI is going to respond with the two RA certificates. So when you had on-premise NDES server, you would have actually seen it that when you install the NDES role, there are two certificates that are issued by the CA and issued to the NDES. Those are RA certificates or registration authority certificates. They end with -RA. The device is going to ask the Cloud PKI to provide these certificates because the device is going to use these certificates in the next step, which we are going to see later. So in the get CA cert, what the device has done, the device has reached out to the SCEP URI and the SCEP service, and it has requested for the two RA certificates. What is the response? The response is the Cloud PKI is now going to respond to the device and provide the two RA certificates. So you can actually go to this URL again and just like from the browser, what I have done is from the browser, I have gone to that same URL and I have done a get CA caps request wherein I have got the response, which is the capabilities of the CA. Similarly, if I go to the same browser and do a get CA cert request, the device will automatically download certificates. Which certificate the device is going to download? The device is going to download the RA certificate. This is the certificate that the device is going to download. Earlier, it used to download two certificates when you had on-premise. Now in the cloud, it has only one RA certificate. So this is the certificate that the device downloads. This certificate is issued by the issuing CA and this is issued to the Cloud PKI service instance. If you double click and open this, you can see more attributes of this certificate as well. So again, just paraphrasing, in the step 4, again when we do a actual demo over there, I will actually go to the browser and do the get CA cert and get CA caps and show you how we are supposed to do it and show you that we are actually getting this response, which is going to correspond with the flow that I'm talking over here. Okay, so until now, what we have done, what has happened is, again, very quickly, the admin made the profile. The admin made the profile in the Intune service. In the profile, the SCEP URI was present. Intune service did the effective member evaluation and it saw whether the trusted root is deployed or not to the same group or not, blah, blah, blah. Then the Intune service reached out to the SCEP service in the next step. It got the challenge password or the OTP generated. Then in the third step, the profile was delivered to the device. Along with the profile, the challenge was also delivered to the device. We were able to track this in the OMADM logs that we just saw over here. And after that, the device reached out to the SCEP service and did a get CA cert and a get CA caps request. The SCEP service responded to the device with the get CA caps request and mentioned the capabilities of itself. These were the capabilities. And then it responded to the get CA cert and provided the RA certificate. Okay, this is what has happened until step 5. Now, let's take a look over the diagram again. Again, we have pretty much the same diagram. Over here, we have the device. Over here, we have the Azure. In the Azure service, we have the Intune service hosted. And on the right hand side, we have the Cloud PKI. Inside of Cloud PKI, we have three components. One is the SCEP service, second is the SCEP validation service, and third is the certificate issuing service. Okay, we have seen until step 4. That is, the device got response from the SCEP service with the get CA cert and get CA caps. Now, what's the next step? The next step is in step number 6, the device is now going to reach out to the SCEP service and it is going to generate something called a CSR. Now, this CSR is, think of the CSR as the actual request for a certificate. So the device now generates a CSR, and in that CSR, it is going to generate a CSR. It's going to send it to the SCEP service. In the CSR, it is telling the SCEP service that I want a certificate and these are the attributes. So what is going to be there in the attributes? In the attributes, whatever we have defined in the SCEP profile, like the common name, the subject name, the subject alternative name, the EKU, the validity, the renewable threshold period, and all of that. So the device makes this CSR and it sends this CSR to the SCEP service. Now what happens is the device signs this CSR using the public key of the RA certificate which it got in the previous step. So remember the step 5 was the device did a get CA caps and get CA cert request. And what was the response to the get CA cert request? The response to the get CA cert request was this RA certificate. Now the device is going to use this RA certificate to encrypt the CSR. What is the CSR? The CSR is certificate signing request. It is a request which is generated by the device and sent to the SCEP service. And that request is telling the SCEP service, please give me a certificate with this common name and this attributes. And it has signed it with the RA certificate. Why has it signed? Why has the device signed the CSR with the RA certificate? Public key, because there is only one person who can decrypt this CSR. And who is that one person? That one person is the person who has the private key of this RA certificate. And who has the private key of this RA certificate? This person. Because this person had the RA certificate to begin with, right? So just a 1,000 feet overview again, a certificate has two keys, the public key and the private key. The public key can be sent to anybody and it is used for encryption. The private key stays with the person who has generated or who has got the certificate, and it is used for decrypting. So the device encrypted the CSR using the RA certificate which it got in the previous step, and then it sent this CSR to the SCEP service so that the SCEP service can now decrypt the CSR using the RA certificate. Now, so in the step 6, you see over here that the device has sent the CSR. Now, this CSR contains, so what does this CSR contain again? As I said, the CSR contains many attributes like the common name to which the certificate should be issued, the validity on all of that. And it also contains the OTP or the challenge. You remember this OTP or the challenge? If I go back, this OTP or the challenge is the same OTP or challenge which was generated by the SCEP service and sent to the Intune service in step 2. So the device has got that OTP and now it is presenting the same OTP to the SCEP service. All right, so back at step 6, wherein the device presented the same OTP to the SCEP service, the SCEP service is now internally forward that request to the SCEP validation service. Now the SCEP validation service is now going to do a comparison and it checks a lot of things. The first thing that is going to check is whether the OTP or the challenge is correct or not. So again, a 1,000 feet overview of how SCEP works is similar to how a transaction might work using a debit card or a credit card in, let's say, Amazon. So the way it works is you go to Amazon, you place an order, and then while you are authenticating, you enter your bank details. The bank sends you an OTP, and then in the Amazon's website, to finish the transaction, you have to enter the same OTP. Once you enter the OTP, now at the back end, a check is made. If the OTP that you entered and the OTP that you got from the bank, if both don't match, then the transaction is not successful, right? So the OTP has to be correct, and the OTP that we receive from our bank that has a time to live, right? Usually of 5 minutes or 10 minutes. If I enter the OTP after 10 minutes, again, the transaction is not going to be successful. So I have to enter that OTP within that 10 minutes of time frame. So keeping that same analogy here in mind, the skip service initially generated a OTP or a challenge. Now the device is presenting a OTP or a challenge. So the skip validation service is going to match whether both are same or not. If both are same, then the skip service is going to trust this device. If both do not match, then skip service is going to deny the request, saying that the challenge password is incorrect. So the as written over here, the first thing the skip validation service is going to check is whether the challenge in the CSR is correct or not. The second thing it's going to check is whether the time to live is correct or not. Like the initially, when you remember, the skip service issued a challenge, it gave it to the Intune service. When it did that, it also stamped the time of creation. Along with time of creation, it has a time to live also, let's say of 5 minutes. So skip validation service is now going to check whether those 5 minutes have passed or not. If it has passed, then again the request is going to be denied. If the challenge is presented within those 5 minutes, then the skip validation service is going to accept it. Just like our bank's transaction, right? If you provide the OTP within 5 or 10 minutes, then the Amazon payment goes through. If not, then the payment is rejected. And then there are a couple of other things also that the skip validation service is going to check. Once it has checked all of that, then the skip validation service gives a green signal. So again, in step 6, what we have seen is the device has reached out to the skip service and provided the CSR. The CSR contained the OTP. The CSR was encrypted using the RA certificate, which it got using the get CS cert call in the previous step. In the next step, that is in step 7, we see that the skip service is reaching out to the skip validation service for validating the request and the challenge. Once the challenge has been validated, now the skip validation service is going to reach out to the certificate issuing service. This certificate issuing service is also, think of it like a component of Cloud PKI. The certificate issuing service is now going to issue a certificate. It's going to issue a certificate on the basis of whatever was there in the CSR. The CSR is going to contain the validity as well as the threshold, the common name, and all of that, right? So the certificate issuing service is going to create a certificate, issue a certificate, and then it's going to provide that certificate to the Intune service so that the Intune service can now deliver that certificate over the MDM channel. So this is a brief of everything that is happening at the background during the certificate delivery. So again, let's take a look over the next steps. So in step 6 over here, as I said, the device is generating the CSR, which is containing the challenge encrypted via the RA certificate, and it is sending it to the SCEP service. So if you look at the event viewer logs, so this is taken from the event viewer logs of the end device. So right now we are looking at the logs at the end device. So over here, this act of the device generating a CSR is logged with the event ID 306. So over here I can see 306, wherein I can see that the device is actually generating a CSR wherein it needs a user certificate. Now after the CSR has been generated, what is going to happen in the next step? The device is going to send it to the Intune service. So over here, as you see, after the CSR was generated, the device sent it to the SCEP service, right? So now we can see it that the device is actually sending the the CSR request to the SCEP service, and you can see the URL as well to which the request is being sent, and this is the event ID. So this act of the device sending the CSR to the SCEP service is logged with the event ID 36, and you can see this endpoint is of Microsoft's endpoint, and this URL is similar to the SCEP URI, and at the end there is PKI client.exe, and it is sending that CSR at that step. Now the next step is the request is sent to the SCEP service for validation. So we won't be able to see any of this in the on-premise. All of this is logged at the service side because the SCEP validation is being done by the cloud PKI, right? So it's happening at the service side. So only Microsoft employees who have access to the service side logs can see this. Earlier, when we had on-premise NDES, and when this validation was done on premise, then we could see the CRP log, and over there we could actually see what exactly the SCEP service is validating. And there were three phases of validation, and it would say that phase 1 passed, phase 2 of validation passed, phase 3 of validation passed. Again, if you are more interested in seeing how the authentication and authorization and everything works with on-premise NDES, you might want to check out my previous video wherein I have shown the CRP logs. But for cloud PKI, the request is sent to SCEP service for validation, and the SCEP service is going to do the validation where it's going to check the challenge and the time to live and all that stuff. Now in the next step, the request post the verification, the request is now sent to the issuing CA, and the issuing CA is now going to issue a certificate. Again, when we had on-premise NDES and on-premise CA, then you could go to the event logs of the on-premise CA, and over there you could see everything happening. Right now, since the CA is in the cloud, you cannot check this logs, but this is what is happening at the backend. That is, post verification by the SCEP service, the request is sent to the issuing CA. The issuing CA issues the certificate as per the request. So currently in Cloud PKI, when we are requesting a certificate, when we are making a SCEP profile, we don't have the option of specifying a certificate template. We cannot specify that, okay, the certificates for the end users should be issued using this certificate template. In case of on-premise NDES, we had that option. So there was a specific registry key, and in that registry key, we had to populate the name of the certificate template using which the client certificate had to be issued. Right now, we don't have that option in Cloud PKI. And over here, the next point is CA protects the certificate package by using the device's public key that it received in the CSR, which means that this certificate which is coming down to the device over here in step 10, this is encrypted using the device's public key. How did the SCEP service receive the public key? So this CSR which was sent, this contained the device's public key as well, which I forgot to mention earlier. So this contains the device's public key. The SCEP service is going to send the certificate over here, and this certificate is encrypted using the device's public key. So this comes down to the device. The device is now going to decrypt it using its own private key. Okay, so that only this device can look at this certificate, nobody else, because this is encrypted. So the device is going to look at the certificate by decrypting it with its own private key, and then it's going to install the certificate. So in step 10, the certificate is delivered to the device via the MDM channel. Once the device receives the certificate, that activity is logged in the event viewer with the event ID 309. So over here in the event viewer logs at the device end, we can see that the device has received a certificate. It has received the certificate from the SCEP service URI. This is the location, and this is the thumbprint of the certificate. So we can see the thumbprint of the client certificate as well, which is ending with 6B. Now, the certificate, once the device has received the certificate, the device is going to install that certificate, right? The certificate needs to be installed. Where is it installed, or where is it present? The certificate is present in the current users. If it's a user certificate, it's going to be present under in the MMC under personal certificate store, right? So once the certificate is received, the certificate is going to be installed, and that is logged with the event ID 39. which we can see in the event via logs as well. And then we can see the certificate in the MMC. So over here you see that the name of the user was OMA, and the subject name was the common name of the user. Therefore it is only issued to OMA. And then over here you see that the it has been issued by, this is the issuing CA and this is the root CA, right? So you can see the entire chain. Now I have not spoken to you guys about the hierarchy or the setup of cloud PKI. I'm going to do that next. But this Intune-DC-CA, this is the root CA, and this is present on premise. And this issuing BYOCA, this is the issuing CA which is present in the cloud. Okay, so again, don't get confused. Just wanted to let you know that what this hierarchy is all about. But the bottom line is that this user has got a certificate which is issued by a issuing CA present in the cloud, and we have tracked the entire log from starting to finishing. Now, how do we see that certificate? Now, the location to see the certificate differs depending upon the operating system. We have already seen if it is Windows, then we have to open up the MMC and then go into the user's personal store and then certificate. If it is an iOS device, then in the device management profile, you have to go into more details, and under certificate header, under SHA-1, you will be able to see the thumbprint of the certificate. For Mac OS, you will be able to see the certificate under the keychain. And for Android, you will have to install an application called My Certificate Apps. And in that application, you will be able to see the certificate. So again, I am going to go back, and understanding the flow is very important. So I hope that we have understood the flow by now, and we have understood what all is happening at the background during the delivery of a certificate, and we have collaborated with the logs at each and every point. Now, when we do the demo, we are going to do everything from scratch, and we are going to take a look over the logs as well. All right, so the next thing I'm going to talk about is the cloud PKI architecture, and this is important because there are two kind of architectures that are possible. Hence, we need to understand the difference between the two, so that if we plan on deploying cloud PKI to our environment, we know which one we want to choose. So there are two ways of deploying Cloud PKI. One is what we can call as Microsoft managed, and the second is something that we can call as bring your own CA. Now let's understand both one by one and understand how to set it up. So first, let's understand the Microsoft managed way of deploying Cloud PKI, and this is the easier methodology, and you can say this is the faster methodology as well. So in Microsoft managed methodology of Cloud PKI, all we have to do is we have to go to the Intune portal, and from there in the Cloud PKI, we are going to make a root CA, a root certification authority. Then we are going to make an issuing CA or a issuing certificate authority. You can think of this issuing CA as a combination of issuing CA and NDES, because this installs the needed NDES component as well, if you would, and it is going to give us the SCEP URI. Now the SCEP URI is going to be given to the device. The device will reach out to the issuing CA. The issuing CA will do whatever we have seen in the flow. It will issue the certificate, send it back to the Intune portal, send it back to the MDM, and via the MDM channel, the certificate will be deployed to the device. So this is methodology one, which is which I am referring to as Microsoft managed. Now this is not the official term that Microsoft is using. Just for reference, I'm calling this Microsoft managed because in this case the root CA is created in the Cloud PKI, and the issuing CA is also created in the Cloud PKI, and we don't have like RDP access to the root CA and the issuing CA. These are all managed by Microsoft. Think of it as like it's a service. Think of it like a software as a service. Like Microsoft is managing the root CA and the issuing CA and the SCEP and the NDES for us, and it's going to issue the certificate. Now, you don't need an on-prem PKI for this to be set up. We are just going to the portal, creating a root CA, next finish. Then we are creating a issuing CA, next finish, which is giving us the SCEP URI. We are taking that SCEP URI, creating a SCEP profile in the Intune portal, next finish, and then everything is ready. You do not need an on-premise PKI. Now, if you have an on-premise PKI, that is also absolutely fine. Let's say that I have an on-premise PKI already, and now I want to make use of Cloud PKI. So that is pretty much straightforward. You can continue to make use of on-prem PKI like you were doing until now, or you can plan and decommission the on-premise PKI. The Cloud PKI and the on-premise PKI are not going to talk with each other. So there is no connection between this and this. So this channel does not exist. Okay. So there is a root. So you might say that there is a root PKI, there is a root CA here, and there is a root CA here as well. Yeah, that is correct. There is a root CA here and there is a root CA here, and both the root CAs are in your environment. That is absolutely correct. But both the root CAs are not talking with each other, and both the root CAs do not know each other. When you create a root CA over here, it's going to ask you for all the attributes like the EKU, the validity, I mean, all the attributes that it is supposed to ask while installing a root certification authority. But it has got nothing to do with the on-premise root root CA. Similarly, this issuing CA has got nothing to do with anything over here. This issuing CA only knows this root CA, and this root CA only knows issuing CA. Again, over here I have created one root CA and one issuing CA. You can create multiple issuing CAs over here as well for load balancing if you would. So this root CA will know this issuing CA and this issuing CA and this issuing CA. Okay. But this root CA will not know anyone on premise. So this is methodology one. Again, just to recap, the methodology one is what I'm referring to as Microsoft managed, in which we create a root CA instance in the Cloud PKI in Azure, and we create issuing CA instance in the Cloud PKI in Azure. Now this issuing CA is going to issue the SCEP certificates, and this root CA and issuing CA have got nothing to do with your on-premise. So again, if you have an on-premise, well and good, you can make use of it the way you were making use of it until now. If you want, you can decommission it as well. But I mean, there is no significance of this on-premise CA as far as issuing SCEP certificates are concerned. So this was methodology one. Now let's talk about methodology two. The methodology two is something called bring your own CA. This is the verbiage that we are using, that Microsoft is officially using. That is something called bring your own CA. So in this case, what is happening is, like in the previous case, we were creating a root CA in cloud, and then we were creating an issuing CA in cloud. In this case, we do not create a root CA in the cloud. We only create a issuing CA in the cloud. So let's call this issuing CA. I know my handwriting should have gotten better over the years, but it still sucks. Okay, so let's call this issuing CA. So this issuing CA is this issuing CA, which I'm referring to as BYOCA, is similar to this. I mean, this is exactly the same. The only difference is in this case, this issuing CA was talking with this root CA, which was also present in the cloud. However, in this case, things are going to be a little different. So what we do is, in this case, we create a issuing CA, which we are calling we are also calling this as bring your own CA as well. I'll let you know why we are calling this the same. But in this case, we are not creating any root CA. This issuing CA is in a way going to be linked with the root CA in the on-prem. Okay, again, let me repeat. In the previous methodology, we were creating a root CA in the cloud PKI and then a issuing CA in the cloud PKI. However, in the second methodology, so obviously you can use this methodology only if you have an on-premise infrastructure. If you don't have an on-premise infrastructure, then how will you link this issuing CA with a root CA? So this root CA needs to be a private root CA. It cannot be a root CA of Amazon or anything like that. It needs to be a private root CA present in the on-premise. So in the previous section, as I said, the root is there in the cloud, the issuing is there in the cloud. So it doesn't matter whether you have an on-premise or not. So even if you don't have an on-premise, everything is fine. But in this case, what I am saying is the issuing CA is going to be linked with the root CA which is present on-prem. So what you can think of is, in this case, the issuing CA is anchored to the root CA present in the on-premise. Now, how do we anchor it? That is something that I am going to explain later. So right now I'm not explaining how to create the root CA, how to create the issuing CA. I just want to explain the concept now, that in case of Microsoft managed, both are there in the cloud. They are not talking with the on-prem. In case of bring your own CA, we only create the issuing CA in the cloud, and the root CA is going to be the same which was before, which is present in the on-premise. And this issuing CA is anchored with the root CA. How is it anchored? We are going to discuss that later on. So this is going to be the two methodologies or the two options for you to choose. So the reason why I brought this up is this is again a 1,000 feet overview of cloud PKI infrastructure. So let's say that tomorrow there is a customer who comes to you and says that I want to deploy cloud PKI, or you sign up for test licenses, trial licenses for cloud PKI, and you want to give it a try. Now these are the things that you need to decide beforehand, before you actually deploy the cloud PKI, whether it is going to be a Microsoft managed kind of a setup, or whether it's going to be a BYOCA kind of a setup. So for BYOCA, only if you have an on-premise presence, then you can make use of bring your own CA. If you don't have an on-premise presence, then you can go with Microsoft managed. Okay. Now we are going to talk about the advantages and disadvantages of all of that later on. But right now, let's understand the two methodologies. Okay. Now that being said, now let's understand how to set up both. All right, so here is the official documentation of Microsoft Cloud PKI, and over here you can see that there are so many things. It talks about a lot of things. Now I am going to go to the section of configure and deploy. So first there is the deployment overview. So first it's talking about what Cloud PKI is, and it talks about the two deployment options. First is Microsoft Cloud PKI root CA, wherein the root is there in the cloud and the issuing is also there in the cloud. The second is bring your own CA, wherein the root is there on-prem and the issuing is there on cloud. So over here it says that deploy Microsoft Cloud PKI using your own private CA, which is there in your on-premise. So with Microsoft Cloud PKI root CA approach, you can create one or more PKIs within a single Intune tenant. Deploying Cloud PKI this way creates a two-tier hierarchy. Why is it creating a two-tier hierarchy? This is two-tier, right? If I go back, this is two-tier. This is the first tier. This is the second tier, right? Because the issuing is below the root. So the root becomes the base, that is tier 1, and the issuing becomes the second layer, if you would, and that is the second tier. Okay. So over here it says that you can create a two-tier hierarchy. You can also have multiple issuing CAs subordinate to the root CA. These CAs aren't public, meaning these root CA and issuing CA, they are not public CA. They are also private CA. Like over here, this was your private CA in your on-premise. This is also a private CA, but this is there in Azure in your tenant. Meaning, let's say that there is somebody else in a different tenant and he wants to get a certificate from your root CA or from your issuing CA. He cannot get that because this is not a private CA, this is not a public CA that we are creating. This is a private CA just for your organization, similar to a private PKI that we create in the on-prem. Okay. Then it says that rather you create both the root and issuing CAs in the cloud. This is the Microsoft Manage the First methodology, which is private to the Intune tenant. The issuing CAs issue certificate to Intune managed devices and they issue it using the SCEP profile. This was the first methodology. This was the first diagram that we spoke about, the Microsoft managed one. Now it is talking about the second methodology, that is BYOCA. So alternatively, you can bring your own certificate authority or BYOCA. With this approach, you deploy Microsoft Cloud PKI by using your own private CA. So over here, you are deploying the cloud PKI by using your own private CA. Okay. All right. This option requires you to create an issuing CA in the cloud that's private to the Intune tenant. Obviously, whatever you are creating there in the cloud, in this option as well as in the previous option, these are all private to your tenant. This cannot be used by anybody else. So that's what it's explaining over here. This option requires you to create a issuing CA in the cloud that's private to the Intune tenant. The issuing CA is anchored to a private CA such as ADCS. So this issuing CA is anchored to a private CA, and this private CA or this PKI is created using ADCS. Uh, and then it is explaining how to anchor it. I'm not going to explain this right now. This is going to come later. So there has to be a way by which this CA is anchored to this root CA in the on-prem, right? So that is what this is talking about. And then it is talking about before you begin identifying the relying parties and then ensure chain of trust and all of that. I'm going to explain what chain of trust and what relying parties later on. But I am not going to get into this right now. Right now, I just wanted you to know that there are these two methodologies that exist. Now let's see how to configure the root and the issuing CA for Cloud PKI. How to set up this methodology, the Microsoft managed one, wherein the root and the issuing are there on the cloud. You can have an on-premise PKI. You might not have an on-premise PKI. It doesn't matter because both are not talking with each other. Okay, so configure root and issuing CA in the Microsoft Cloud PKI or the Microsoft managed one. This article describes how to do that. Prerequisite is, well, obviously, the prerequisite is you need to have Intune license and Intune tenant and subscription and all of that. And then it's talking about RBAC and all of that. So creating a root CA is very easy. You just have to root CA and the issuing CA in the cloud is very easy. I mean, both are very easy. It just takes less than 5 minutes. You just have to go to tenant administration. Again, I will show all of this in the demo, but I just want to give you a sneak peek by going through the documentation. So you have to go to the tenant administration and then cloud PKI, and then over here click on create. And when you click on create, you have an option of creating a root CA. And when you're creating a root CA, you have to provide a lot of information like the name of the root CA, the description, the CA type. This is going to be a root CA, therefore the CA type is going to be root CA, the validity of the CA, the EKUs of the CA. So the extended key usage of the CA determines whichever certificate the root is going to issue, they are going to have the similar capabilities. So you have to select the EKUs, and then we have an option of providing a custom EKU as well. And then over here, it's giving you some suggestions. We will see all those suggestions later on. And then you have to create a common name and encryption algorithm and all of that. And then next, finish. And when you finish, then this root CA is now created. Once the root CA is created, which is this one, the root CA is created. Now you have to create a issuing CA in the cloud. So the step 2 is creating a issuing CA in the cloud. Um, So now we are going to create an issuing CA, and then we already know these points, right? With Microsoft Cloud PKI, you don't need to install and configure an NDES server or Intune connector and NDES server URL and all of that. We have already seen this when we did a comparison between Cloud PKI and the on-premise NDES methodology. So again, creating a issuing CA is again very simple. You just have to go to the same location, that is tenant administration Cloud PKI, and then in the CA type drop down, instead of root CA, you are going to select issuing CA. And then when you select issuing CA, it is going to ask you, this is important. So when you are creating an issuing CA, so this is a issuing CA, right? And this was also a issuing CA. In this case, the issuing CA is talking to the root. In the previous section, this issuing CA was talking to the root, but this root was there in Azure. In the later one, this root was there in on-prem. So when you are creating the issuing CA, you have to mention that whether your issuing CA is going to talk to a root in the on-prem, or whether your issuing CA is going to talk to a root which is there in Azure. So that is what we are selecting over here. The CA type is issuing CA, and then it is asking for this issuing CA who is going to be the root CA source. Whether it is going to be a root CA, whether it is going to be this one, which is a root CA in Azure, which in this case you can refer to as Intune, or whether you have the root CA on premise, which is BYOCA's methodology. So you have to either select Intune or bring your own CA. So right now we are talking about an instance wherein both are present on the cloud. Therefore, when you are creating this issuing CA, when you are linking it to a root CA, you will select Intune because both are present in the cloud. So we select that, we select Intune over here, and then we select, it's telling you the same thing. And then again, you have to select a validity for the issuing CA, the EKUs, and then you have to provide the location, the state, and organization, and all of this. All of these are not mandatory. These are all, I mean, a lot of these are optional. And then next, create. Once you create over here, you can see it is so simple. Now there are two CAs that are created. The bottom one is the root CA, and the one above it is the issuing CA. Okay, and then it shows you the common name, the issuance time, the expiration, and all of that. So this is how the root CA and the issuing CA can be created in the cloud for Microsoft managed kind of a setup. Okay, so now let's take a look over how we can configure the BYOCA kind of a scenario. So let me just open up the second link which says that configure bring your own CA for Cloud PKI. So in this case, we are not going to create the root. The root is going to be on-prem. We are only going to we are only going to create an issuing, and that issuing will be linked to the root on-prem, not to the root present in the cloud. So going back, the issuing will be linked to the root on-prem, whereas in the previous case, the issuing was linked to the root on cloud. So coming back over here, all these things are pretty much the same. I'm just going to scroll down. So this says that this article is going to describe how you can configure Microsoft Cloud PKI with your own on-prem CA. This is the Intune supported BYO CA deployment model lets you create and anchor a private issuing CA in the cloud to your on-premise private CA. The prerequisites are pretty much the same, and then there is RBAC. So the steps for this is pretty much the same. You go to tenant administration, Cloud PKI, then you create, and then in the drop in again you are going to select a issuing CA. In this option, when you were selecting a issuing CA, it was asking you what kind of route you want to link it to. So in that option, what did we select? We selected the route to be in the cloud. But in this case, in the second case, we are selecting the root CA name. We are selecting bring your own root certificate, which means my root is there in the on-premise. Then you have to select the CA type, the root CA source. This is what we selected over here. Then the validity period, EKU. These all remain the same. Then the type, and then you can create a custom EKU as well. Then the subject attributes and common name, these are all of these are not mandatory, and pretty much the same thing, that is you select the encryption and next finish. Once you are done with that, then there is one more step that needs to be done in this case. So in this case, as I said, the issuing CA is anchored to the root CA. How do we anchor it? That is what we are going to do over here. So the way to anchor it is we download a request from here and then we take that request to the CA over here. The CA is going to look at this request which has come over here, and then it is going to, in a way, approve this request, and then this request comes back over here. So think of it like I take something from this issuing CA, take that to the root CA approves it, and that approved something is taking back to the issuing CA. And now the issuing CA is anchored with this root. So that is pretty much what this is also going to talk about. So what we do is from here, we download something called a CSR, or a certificate signing request. So once we have down, so over here, that's what we are doing. We go to the properties of the issuing CA. So this issuing CA in the portal will have a tab called properties. So we will go to the properties, and from the properties, we will download something called a CSR, or a certificate signing request. So we download the CSR. I will show you the UI shortly. So we download the CSR. Then we go to the on-prem server, then we go to the root CA, and then we get that CSR. Then we get this CSR signed by the root CA. And then that signed CSR is uploaded back into this issuing CA. So it's very simple. In the BYOCA, we create the issuing CA, or the BYOCA methodology. We download the CSR. We take that CSR to the root CA signs it, sends it back to the issuing CA, and now the issuing CA is anchored with the root. Now, how does the root CA sign this CSR? There are two methods. Option one is using a tool called Certificate Authority Web Enrollment. Option two is using a command line tool. So there are two tools available. Both these tools are available here. So we can use tool number one, which is a web enrollment, which is a web UI, or tool number two, which is a command line. And both of these are going to do the same thing, that is sign the CSR. Okay, so it is saying option number one, which is the UI, which is a certificate authority web enrollment. It's nothing much. You just have to go to a URL and then upload the CSR, and then it is going to sign it, and then you can download the signed CSR. Or you can do the ADCS command line tool, which also pretty much does the same thing. You have to run a few commands. That is pretty much it. Now, once the root has signed the CSR, either via this methodology or via this methodology, once this CSR is signed, now that signed CSR is going to upload it back into the issuing CA. So that is what the step three is. Upload signed certificate to enable the BYOCA. Until you do this step, that is download the CSR, take it to the root, assign that CSR and upload it back. Until then, this issuing CA is not functional. Once you do this, once you take the CSR, get it signed by the root CA and upload it back, that is when this the issuing CA is anchored with the root. That is when this issuing CA becomes functional. So this is what this is talking about. To complete the BYOCA Cloud PKI issuing CA, signing is required to enable the CA to start issuing certificates, and it is pretty much simple. You just click on this and then you upload the signed certificate. That is pretty much it. Once that is done, then you have to create the SCEP profile and the trusted root profile. We already know how to do that, so I'm going to skip all these steps. Now, I did not take a lot of screenshot because I was lazy, but there are a lot of documentation which are there in the internet. Like this one talks about how you can set up BYOCA. It pretty much talks about the same thing. First, it is creating the root, then it is creating the issuing. When it is creating the issuing, it is over here. It has selected BYOCA option, and then it enters all those same attributes. Once all of those are entered, then then you download the CSR. So this is the option where you get an option to download the CSR. So we are downloading the CSR from where? We are downloading the CSR from here. So this is the option to download the CSR. You click over this, you download it. Once the CSR has been downloaded, you go to your on-premise CA, and then either you can use this certutil command tool that I have used over here, or you can use the web enrollment tool, and then you sign that CSR. Once you have signed that CSR, then you come back over here, and then you have an option of uploading. So you download it from here. Now you're uploading the signed certificate over here. You just browse and then you upload the signed certificate. So once you have uploaded the signed certificate, you are all good to go. That is pretty much what this is also talking about, and then it's talking about how to create the SCEP profile and how to issue it, which we will see later on. So this is again a difference between BYOCA kind of a scenario, wherein just again very quickly in case of BYOCA, the from the BYOCA we are downloading the unsigned CSR. We are going to the issuing CA or the root CA, which is present in the on-premise. We are using either the web enrollment tool or the command line tool. The end goal is signing that CSR. Once that CSR is signed, the signed CSR is uploaded back into the issuing CA present in the cloud. So that now the issuing CA in the cloud is anchored with the root or the issuing CA in the on-premise. Okay. All right. So details about Cloud PKI, we can create a root and issuing in the cloud, or we can only create the issuing in the cloud and the root will be there in the on-prem, which is BYOCA. And then the RSA key sizes that are supported are 2048, 3072, and 4096. For security reasons, anything less than this, like 1024 or anything less than this, is not supported anymore. And the hash algorithm is going to be SHA-256, SHA-384, and SHA-512. These are the hash algorithms that are supported. Any purpose EKU is not supported. So when we create a CA, we have to mention what EKU we are going to select. Like over here, if I scroll all the way to the top, uh, 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 over here we have to select the EKU. So over here you can see, so the EKU means, EKU is stands for extended key usage. It means what the certificate can be used for. So the certificate can be used for anything, right? It can be used for client authentication, like authenticating to Wi-Fi or VPN, or it can be used for, let's say, signing an email, or it can be used for, let's say, server authentication, or I mean, that certificate can be used for anything. So that is what this EKU is being represented over here. Now there is also an EKU called any purpose, wherein you don't mention that what this EKU, what this certificate will be used for. You just say it can be used for anything. Now that is not very secure. Therefore, in the EKU, we cannot select any purpose or anything. We have to mention what the certificate is going to be used for explicitly. Now, in the on-premise world, we have an option of mentioning any purpose as EKU, but in the cloud PKI, for security reasons, we have to mention what the EKU is going to be for, is going to be used for. Okay, so that is what this deck was talking about. This slide was talking about. Any purpose EKU is not supported. So what are the things that we can do from Cloud PKI? We can manage the certificate life cycle. That is, we can issue a certificate. We can revoke a certificate. Okay, that is what the life cycle of a certificate is, right? Issuing it, using it, revoking it, and renewing it, right? So if you do, if let's say the certificate has a validity of 1 year, then you need to renew that certificate as well. So by certificate life cycle, I mean issuing, revoking, and renewing. So all these three can be done in case of Cloud PKI. Reporting and dashboard, that is also there. We will take a look over the reporting and dashboard where we can see how many certificates has been issued, how many have been revoked, to which UPN the certificate has been issued, what is the thumbprint of the certificate, and everything, right? Then we can audit as well. if there is any admin who is going to the console and he is creating a root CA, or he is creating a BYOCA, or he is doing any admin related activity, all of this are logged in the audit logs as well. And then there are RBAC permissions and scope tags as well if you want to scope it. Now auditing and reporting, like over here, there is over here when I go to the portal, there is a tab called monitor and in the cloud PKI, and then it is going to tell me how many certificates has been issued, how many are expired, if there are any certificates which are revoked, what is there in total. It is going to tell me the subject name or subject name of the certificate to which the certificate has been issued, the UPN, the device name, this is the name of the device, don't get confused, the status, the thumbprint of the certificate, and when you click on that, it gives you the same information. It gives you the CRL as well. So CRL is, think of it like a endpoint where the certificate is going to go to check whether the certificate is revoked or not. It is nothing but it stands for certificate revocation list. And then if you click over here, you have an option of revoking a certificate as well. So what I mean by that is all of this is I mean there is very good auditing like we have already seen, and there is very good reporting as well, where we can get a uh, where we can get a very granular view into how many certificates are issued and what are the parameters, and we can get a bird's eye view as well. So this dashboard is a bird's eye view which is telling you all the certificates that are issued and whatnot. So remember again, guys, what are EKUs? EKUs are extended key usage, and the EKU of a certificate determines what that certificate can be used for. If that EKU of a certificate is client authentication, only then that certificate can be used for authenticating a client. That is when we connect to a Wi-Fi or VPN, the client is trying to get authenticated, right? So only if it has client EKU or client authentication EKU, then only it can be used for client authentication. So we have to remember that EKU is very important, and we select the EKU when we are making the SCEP profile as well as when we are. So the way the EKU works is, again, let me just explain this right now. So when you create a CA, there are, let's say, 10 EKUs, okay, which the CA can have. So when you are creating the CA, you have to select which of these EKUs your CA wants. Make sure that you are selecting this wisely, because once you select it, once the CA is created, you cannot add it. Like let's say that there are 10 EKUs. Out of these 10 EKUs, you selected only first 4 of them, which means that the CA can issue certificates with these 4 EKUs only. So tomorrow, if you want to add 3 more EKUs, you cannot do that. You will have to create a new CA again. So again, when you created the CA, you selected these 4 EKUs. Now, when you created the root CA, now when you create the issuing CA, then you will get an option of these 4 EKUs only. You will not get these 4 because the root only does not have these 4. Then how can the issuing have these 4? So in the issuings, this is the issuing, this is I, this is supposed to be an I. So in the issuing, now you will get an option of these 4 only. So let's say that out of these 4, you select only these 2. Okay, so now the issuing has an option of issuing only certificates with these 2 EKU only, which means that now when you select a SCEP certificate, SCEP profile, in the SCEP profile also you have to select the EKU. Now you have an option of selecting between these 2 EKUs only. So either you can select this one or you can select this one. What I mean by that is, in the cloud PKI infrastructure, EKUs have to be defined in 3 places. First is in the root when you're selecting the root CA. Second is when you're selecting the issuing CA. And third is when you're making the SCEP profile. Now this is the master list. So the recommendation is having as much as EKU over here, so that later on you don't end up having the need to add more EKUs, because later on you cannot add EKUs. You can only select the EKUs when you are making the CA, root CA or the issuing CA. So again, you select the EKU when you are setting up the root. whatever EKU you selected while creating the root, those EKUs are only present to be selected when you are selecting the EKU for the issuing. So this is like a master list. From this master list, you select something. Only what selection you made in step 1 are presented as an option in step 2. Now, if you select everything over here, then everything will be available as an option for the issuing CA. And whatever you select over here will be available for usage in the SCEP profile. Again, don't get confused. I will show all of this in the demo, but just wanted to talk a little bit about EKU and how important it is to select the right EKU when you are creating the root CA or issuing CA, because it cannot be modified later on. So EKU has to be selected while creating the root issuing CA as well as the SCEP profile, which flows down. That is the most important word here, which flows down. Whatever you select over here, only those selections are available over here. And out of that, only the SCEP profile can choose and deploy a certificate. So planning ahead is very important, as EKU cannot be added later on. Once the issuing CA is created, or once the root CA has been created with a specific EKU, you are bound to that. If you want another EKU later on, you cannot add. You will have to create a new root CA or a new issuing CA. And any purpose EKU is not allowed, because that if any purpose was allowed, then you won't have to do all this drama, right? You could just select any purpose here, just any purpose here, and then any purpose here, and then that any purpose could be used for anything. May that be for email encryption, or may that be for Wi-Fi or VPN or server auth. But then any purpose is not actually secure, because it can be used for any purpose. That is why any purpose EKU is not allowed to be selected in case of Cloud PKI. Okay, now there are a couple of things that we need to keep in mind. So when we said that we can create a root in the cloud, so let me just go back. So over here, I said that we can create root in the cloud and issuing in the cloud, or we can only create one issuing in the cloud. Now, um, there is a limit to this. You cannot create one root in the cloud and then 10 issuing CAs. Because what happens is, whenever you create a certificate, whenever you create a CA, it has its own certificates, right? And the certificate is going to have its private key and public key, and the private key has to be stored securely. So where is that private key going to be stored? The private key is going to be stored in some place in something called a HSN. Now that HSN is a physical entity, so there is a limit to number of issuing CAs or number of root CAs you can create in the cloud in your tenant, and that limit by default is 6. The reason why we have set this to 6 is because then there will be 6 HSNs that will be needed, because we cannot allocate unlimited number of HSNs to each tenant, right? So there has to be a limit. However, I think 6 is good enough, which means you can either have 3 root plus 3 issuing, or you can maybe have 1 root plus 5 issuing. So you can have any combination. The total has to be 6. Okay, over here the total has to be 6. And I guess we are clear now why the total has to be 6, because each CA has its own certificate. Each certificate has its own private key. The private key are going to be stored in HSN for security, and HSN is a finite number. HSN is not like infinite. Therefore, we cannot let people create infinite number, because if it is infinite, what if tomorrow for testing anybody creates 1000 issuing CAs, which means that there will be 1000 HSNs that will be required, right? But HSNs is a finite resource. Okay, so that is what it is talking over here. Um, uh, 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 let me We can create a maximum of 6 CAs, which can be any combination of root and issuing. And I think 6 is good enough. If in case you want more than 6, then the recommendation is reaching out to Microsoft via a support case, providing them a business justification on why you need more than 6, and then they will be able to help you out. They will create an exception for you, and they will figure out your, I mean, they will see whether your justification, how fair your justification is. If your justification makes sense, then they will help you out. But by default, for all the tenants, it is the number is 6. However, it is not like a hard coded number that it can never be increased from 6. It might be if you provide a valid justification to the Microsoft support, and it's their call. They are going to decide whether your justification actually makes sense or not. Now, when we create the SCEP profile, if you guys remember the flow, we create a SCEP profile. That SCEP profile comes down to the device. Now that SCEP profile contains the SCEP URI. So the recommendation is not, let's say that you can enter, let's say that this is a SCEP profile. In the SCEP profile, you enter the SCEP URI. Now you have an option of entering multiple URIs, right? So if you guys have used NDES on-prem, and if you have load balancing set up, then what you would have is you would have two NDES. Both the NDES will talk to different app proxies. Both app proxies would have different URLs, and both the URLs will be added to this profile, so that if the first URL fails for any reason, I mean, if the first URL pointing to the app proxy is not functional, or the first NDES is not functional, then the second URL will automatically fail it over, or it will load balance. So over here you have an option of having two URLs. Similarly, when you are creating a profile in the SCEP profile using the URLs which are of Cloud PKI, you can have multiple URLs as well. But let's say that the first URL is something that you have got from issuing CA from the cloud. Don't mix it with a URL from your on-prem. Let's say that you have an on-prem NDES as well, and now you just wanted to try out the cloud PKI. So you created a issuing CA, and you got a SCEP URI from the cloud as well. So don't do like you are adding a cloud PKI URL over here in the SCEP profile and a URL from the on-premise NDES over here. That is not a supported scenario. So let me just show you guys very quickly. So I'm at my portal, and over there, let's say that this is an NDES profile. So when I go to the NDES profile, and if I click on edit, so this is what we select. I will show all of this to you guys later on. But just remember that at the bottom, you see that there is an option of entering SCEP server URLs, and you can enter multiple URLs over here. I can enter multiple URLs. Just let's say that you enter two URLs. You don't, the recommendation is don't mix and match. Like this URL is of an on-premise NDES. The recommendation is if I have an on-premise NDES and if it has an URL, in one profile, don't mix an on-premise NDES URL with a URL of a cloud PKI. So either you have multiple on-premise NDES URLs and you add them over here, or you have multiple cloud PKI URLs for NDES and then you add them in one profile. But don't mix and match. Like over here, I have one which says load balancing NDES. Let's see if it has more than one URLs, because at some point I had multiple NDES working. Yeah, over here you see that I had three NDES servers, NDES 1, NDES 2, and demo NDES. And I had load balanced all three. Now all three of them are present on premise. I don't have a setup wherein two are on premise and one is cloud PKI hosted, because that is not a supported scenario. Just something for us to remember. So no mix and match of SCEP URIs, that is important. More than 6 CAs, is it possible? Yes, it is. Subjected to Microsoft for validation, you have to provide a business justification. And then certificate revoke scenarios is something that we have to remember. So what happens is we have an option of revoking a certificate from the Intune portal. But remember that if you just revoke a certificate, then and if the SCEP profile is still targeted to that user, then at next check-in, the service will issue a new certificate to that user or to that device. So if you are revoking a certificate, and if you do, if let's say that you have a user who was using Wi-Fi and he no longer needs to use that Wi-Fi because he has moved to a different location. So what you can do for security purposes, you can revoke the SCEP certificate that was issued to him. But once you have revoked it, he is still targeted by the SCEP policy, right? So at the next check-in, he would get a new certificate. So to make sure that he doesn't get any certificate, you have to remove the targeting of the SCEP profile also, because just revoking the certificate would mean that that certificate no longer is valid, but Intune service will deploy a new certificate if the SCEP profile is still targeted to that user. Okay, so we have done enough talking, and we have spent a lot of time in talking about what the flow is, what the setup is. Now let's get right to the demo and let's set up everything from scratch. Once we are done with the demo of deploying a SCEP certificate, then I will talk to you guys about how to use that certificate for authentication and what is chain building and whatnot. So let's switch right to the demo. Alright guys, so for the demo, I am here at my portal, and the very first thing that we have to take care of is the licensing. So I'm going to go to my user who is going to enroll the device and take a look over his licensing. Currently, he just has the A3 or A5 license and the license for Intune endpoint privilege management. This is not going to make it. Therefore, I'm going to assign the cloud PKI license as well. And there you go. So the cloud PKI license has been assigned. Once the license has been assigned, now I can set up the cloud PKI. For that, I'm going to go to tenant administration, and then over here there is this blade called cloud PKI. Once I click over here, you can see I have not created any CAs or anything like that until now. Therefore, it doesn't show anything. And then it says that 68 days are left in the trial, after which I will need to buy licenses. Okay, so far so good. I think the page is still loading because this is grayed out. So let me just refresh the page. All right, so just did a refresh. Now the create option shows up over here. Going to click on create. First thing is it's going to tell me to name this. So let me just call this EAI and then root CA. Okay, the CA type is going to be either root or issuing. If we are doing bring your own CA, in that case, we will directly be creating issuing. Right now, I want to create both root and issuing in the cloud. Therefore, first I'm going to create a root CA. The validity period is going to be 25 years. And then I have to select the EKUs over here. Remember, the EKUs that we select over here is the master EKU, and amongst these only I can select the EKUs for my issuing CA and for the SCEP profile. So for demonstration, let me show you guys with two EKUs only. First one is client authentication, and the second one, let's say server authentication. Okay, and then I have to give the common name of my root CA over here. So let's call this EAI root CA. Rest are optional. Okay, over here key size algorithm, I'm going to select RSA 4096 and SHA-512. Clicking on next. Scope tags, I don't want to put in any, and then review and create. Once we create this, we cannot edit any attribute of this certification authority. So let's just wait for it to get created. And there you go, it gets created. Let me just do a refresh over here. Okay, so there you go. The name that I provided, the common name is what shows up over here. The status is active, type is root. This is the common name. And then again, the common name of the root is showing up over here, the issuance time and the expiration. Okay, if I click on this, I go to the same page over here. It says that you can't edit the settings of the certification authority once it has been created. And it gives me the option to download the certificate. So this is going to be the root CA cert. So let's take a look over this. So if I double click and open the certificate, this is what it looks like. It has been issued by the EI root CA. It has been issued to the EI root CA, meaning this is the trusted root certificate. And in the details, you can see it has got SHA-512 like we had chosen before. And then it has the relevant organization, relevant country that I had chosen while I was setting it up. And in the EKU over here, you see it has got server authentication and client authentication, the EKUs that I had chosen while we were selecting the CA. And then it has got key usage as well. Okay, so far so good. Now the next thing we are going to do is we are going to create an issuing CA. So let's call this issuing CA. and this issuing CA, the CA type is going to be issuing CA, and it is going to be anchored to the root that we have just created in the Cloud PKI. So over here, I'm going to select Intune as the root, and then it is going to look for all the roots that are there in my tenant, and it is going to show up over here. I have only one root, therefore that one root shows up. If I had multiple roots, then multiple roots will show up over here and have the option of anchoring this issuing CA to either of those roots. So I'm selecting this over here. Now the validity period, let's select 10 years over here. Now I have to select the EKU. Over here you see all the other EKUs are grayed out, and I can select amongst these two only because my root CA has these two only. My root CA is capable of issuing certificates with these two EKUs only. Therefore, the issuing CA is limited to this list. So let me just select client authentication and server authentication both. Both are added. Let's add the common name. Okay, so far so good. Next, I don't want any scope tags, and then create. So this is creating the issuing CA now, and along with issuing CA, you can think of it like it's creating a NDES as well. So if I just, and you saw how fast that was. I did not fast forward the video. You are seeing this in the real time. I just refresh this, and over here you see that EI root CA is also created. And then issuing CA is also created, which we have created just now. If I click on the issuing CA and if I go into the properties, you see that the issuing CA has a SCEP URI. This is the URI that my end devices are going to be provided with, and then they have a certificate revocation list as well, and then they have a AIA as well. All right, so far so good. So now first thing that I'm going to do is I'm going to show you how easy it is to do a search deployment via this methodology. I'm not going to track any logs this time. Then I will be doing a BYOCA, and then I will be showing you all the logs. So the first attempt is just showing you how fast and easy and smooth it is without complicating it with the logs. Okay, so then this all looks good. Uh, uh, uh. So now what I'll have to do, I will have to download both the root certificates for chain building. So first I'm going to go to the root CA, and I have already downloaded the root certificate in the root CA. Now in the issuing CA also has a certificate. If I just download this, this is the issuing CA certificate. Let me just open it up and show you guys what this looks like. So this is the issuing CA certificate. So it has been issued by the root and issued to the issuing. The earlier one that we saw, that was issued by the root and issued to the root. This is issued by the root, issued to the issuing, and then everything else is going to remain the same. The validity from and the validity to, over here you see it has a validity of 10 years like we had chosen while we were setting it up, and then the hash algorithm and everything else also matches, and then it has the subject name that we had chosen. Okay, so far so good. Now let's go ahead and create a profile. So let me just duplicate this tab because I'm going to need this information later on. So, okay. So now let's create new policies. The first policy that we are going to create is for trusted root profile. So if you just scroll down, you have the trusted certificate profile. Just click on create. Just call this CPKI trusted root, and then let's just call this MM meaning Microsoft managed, because I'm going to do a demo for BYO bring your own CA kind of a scenario as well. So let's do a next, and then this is very easy. We just have to upload the certificate over here. So so these are my certificates. I'm just going to select the EAI root CA. Sir, this is the root certificate. I'll just click over this, next, and in the assignment, let me just assign this to all users. You can assign this to a group as well. I'm just making it simple. So this is assigned to all users. Next, next, create. Okay. Now let's create the, I'm not going to assign the SCEP profile yet, but I'm just going to create it and keep it ready. So let me just refresh this and make sure that the root profile is created. There you go. This one is created. Now let me just create a SCEP profile. The methodology of creating a SCEP profile remains the same as before. So let's create the SCEP profile. Create. Let's just call this EAI CPKI SCEP MM, and then next. Okay, now we have to configure all the different attributes. This is going to be a user certificate. The subject name format, let's leave this to common name only. This looks good. And common name, yes, this is fine. I don't want the email because I don't know whether the user has an email or not. Over here, let's use the UPN, and the value is going to be CN is equal to username, which means, so over here, this is very simple, right? The subject name format, it is asking what is going to be the subject name that is printed in the certificate. So I'm populating it with this variable called username. So whatever the name of the user is, it will be populated over here. And then subject alternative name, I'm using the UPN. Certificate validity, we have to make sure that this validity is not more than the validity of the issuing CA or the validity of the root CA, because obviously the issuing CA cannot issue any certificate which has a validity of more than the issuing CA itself. So over here, let me just put this to, let's say, 1 month. Okay, we could have done more also. I'm just showing you the minimum one. The KSP, let's do a, my machines are all virtual machines. So let us do a enroll to software KSP, and the key size usage, let's select both digital signature and key encipherment. Key size bit is, let's say, 4096. Hash algorithm, let's select both. Now I have to link this SCEP certificate with the root certificate. So it is asking me to which root do you want to link it. I want to link it with this root that I have just created. I just select this and do a OK. It's asking me for the EKU. Now I cannot select any purpose EKU if I select over here. um I mean, it's not giving me any error, but it's not going to work. I am going to select the client authentication EKU over here, and then the renewal threshold is going to be 20%, and over here I have to enter the SCEP URI. So I'm just going to copy the SCEP URI from here, then I'll talk more about it. So this is the SCEP URI. Now earlier, if you remember, if you had an on-premise NDES, then if you would go to the SCEP URI, it would give you the 403 forbidden error and all of that. That doesn't happen anymore. It doesn't give you a 403 forbidden error, but I'll show you how we can find out the get CA cert and get CA caps. So I'm just going to do a next, and before I assign, let me just go back and see uh, 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 what is the status of the profile for this device. So I'm just going to go to the devices, and this is my device. Let's see if it has got the trusted root profile. So I go to device configuration. It has not got it yet. So let's just go to the device and run a sync. I want the, this is my device, the device is already enrolled. I want the trusted root profile to successfully come first, and only then I want to assign the SCEP profile. Uh, uh, uh. So let me just go to accounts, and I'm just going to quickly run a sync. Now I have generated a sync, so it's going to come down. While this comes down, let's create the trusted certificate profile for the issuing CA as well. So right now, we have two trusted certificates, right? Let me just go back to tenant administration and show you what I'm talking about. So the root certificate has its trusted certificate which we have downloaded, and the issuing certificate also has its trusted certificate which we saw in the properties and which we downloaded from here. So this certificate which is issued by root and issued to the issuing CA, this also needs to be deployed. So let's do that also real quick, and then we are going to deploy the SCEP certificate profile. So in total, there are three profiles that are going to be deployed. First is the certificate root, first is the trusted root certificate, which involves the certificate issued by the root and issued to the root. The second is the other trusted root profile, which involves the certificate which is issued by the root to the issuing, and the third is the SCEP one. So I'm going to go back to Windows configuration profile. So I'm going to click on create a new policy, And again, this is going to be Windows 10 and later, the same drill again, real quick. And this time I'm going to select the second certificate, which is issued by the root and issued to the issuing. Again, very quickly, the certificate has been uploaded. It's going to go to the computer certificate store. Next, let's just assign this to all users. Next, and then create. So let's just wait for these two profiles to come down to the device, these two certificates to come down to the device, and then we are going to assign the SCEP profile, which is also going to be assigned to all users. Remember, the assignment should be symmetric. So whatever we are assigning for the root and the trusted, the same group should be used over here. Therefore, I'm using all users in both the locations. So CPKI, these are my two profiles over here. I have run a sync at the device end. Let me just initiate another sync. And then let me just open up the MMC and show you guys the certificates as well. So I'm just going to click on add and add the user account. So I've added the user store as well as the local computer store as well. Let's just wait for a couple of minutes and then the certificates are supposed to show up in the trusted root certification authority, right? Okay, so let's quickly check at the portal. What is it showing if I go to device configuration for this device which I had enrolled? Now it shows that the root one has come down. It has pushed some applications as well, which were also pushed to all users. So the root one has come down. Soon the intermediate one should also come down. So if I go to the device and if I go to trusted certification authority over here, you see that the certificate issued by the root to the root is here, and the certificate issued by the root to the issuing is here. So my certificates are here, both the root and the issuing. So far, so good. So now I can go ahead and deploy the SCEP certificate as well. The SCEP certificate will come up in the personal store. So if I expand the personal store and go to certificates, right now you can see that there is this Windows Hello certificate over here. But right now there is no SCEP certificate that has been deployed. So I'm just going to go over here. All users has been added. I'm just going to do a next, and then create. Then again, I'm going to run a sync at the device end and then wait for things to show up. All right, so let's run a sync from the portal as well. It has been a couple of minutes, and now let's go back to the device. And if I go back into the personal store, there you go. So now you see that a certificate has been issued by the issuing CA, which is there in the cloud, to the user Greg S. And this is just the username because in the common name I had selected the username only in the SCEP profile. The validity is as I had selected 1 month only. And if I scroll down, it is going to have the issuer and valid to valid from the signature algorithm. And then what I'm interested to show you guys is the thumbprint, which starts with 35 and ends with 209. That is what we will be seeing it at the portal as well. So let me just go back over here, go back to device configuration. And over here you see that the SCEP profile has successfully come down. If I go to the portal over here, in the profile over here also it shows that has succeeded. Let me go to tenant administration and go to Cloud PKI and see the monitor section over there. So if I go into the issuing CA, over here it should show now one certificate. It sometimes takes a while. Let me just click on view all certificates and see. Yeah, it has not reported yet, but very soon it's going to show all the details of the certificate over here as well. So hence you can see guys how easy it is to set up a root CA and the issuing CA, which in the backend also sets up something like an NDES and gives us the URI, and we just have to create the trusted root profiles and the SCEP profile and then just deploy the same. And you saw how simple it was. There is no much of troubleshooting that also needs to be done in this case. Not much of logs are there to be seen. However, I'll show you guys the logs very soon when I am going to do the BYOCA kind of a setup. But I hope we have by now understood how to get started with Cloud PKI with the root CA and the issuing CA in the cloud. All right, so took about a few hours, and now if I go back into the issuing CA and if I click on view all certificates, now you see that all the information has populated, like the subject name, UPN, the device name to which the certificate has been issued, and most importantly, the thumbprint of the certificate. So yeah, all of this looks good. So now let's just go back and do the BYOCA kind of scenario, and this time we are going to track all the logs at the device end. So the process is the same. I'm just going to click on create and let's just call this BYO uh, issuing CA. The CA type is going to be an issuing CA, and the source, the root source is not Intune, because Intune means that the root is also present in cloud. In this case, it's going to be bring your own root CA. The validity period cannot be configured over here, because in this case, the validity of the issuing CA would depend upon the validity of the root that we have in our on-premise. The EKUs can be selected from here. So I'm just going to select client authentication and let's say server authentication, and let's just name this. All right, so these are the informations that I decided to fill in, and now I just do a next. There is no scope tag, and then we are good to do a create. Remember, once you create this, you cannot edit this. And over here, you see that it says that a certificate signing request or a CSR must be signed and uploaded before the CA is enabled. So let's see what that is. So I'm just going to click on create and give it a couple of seconds. Okay, so it says that has been successfully created. Let me just refresh this. And over here, you see that BYO issuing CA has been created. But over here, it says that the status is signing required. And it also says that has not been signed yet. And both these are not applicable. However, in the previous case, in the issuing CA, that was not the case, because this issuing CA was linked to this route. Therefore, we did not have to do any CSR signing and all of that. However, in this case, this issuing CA is linked to the root in my on-premise. Therefore, it is telling me to sign a CSR. So it's very simple. I just have to click on this and I have an option of downloading the CSR. I just have to download the CSR from here, sign it, and then upload the signed CSR. So I'm just going to click over here and it has downloaded the CSR. All right, so I am at my domain controller now. So let me just quickly show you the host name. This is my domain controller, and this is the request file or the CSR that we have just now downloaded. So we can just open this with Notepad. Uh, 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 and over here you can see this is the request. So this is the request that we actually need. So I am just going to copy this request from here, and now in my, so my domain controller is my CA. So what we need to do is go to the certification authority, not the domain controller. And when you go over there, you need to go to the search serve URL. So you need to go to the FQDN of the server slash search serve, and then this page will open up. So this is the CA web enrollment page, and from here we can request a certificate or we can get a CSR signed. So again, what I've done is I have logged into the certification authority and I have gone to the search serve URL, and then I'm going to click on request a certificate. Then I am going to click on this option which says submit an advanced certificate request. So I'm going to click on that, and over here I have to enter the base 64 encoded certificate request, and I have already got the base 64 encoded certificate request from the file that I downloaded from the portal. So I'm just going to copy it from here and I am just going to paste it here. So over here you can see that this is pasted. I'm just going to go to the very bottom. Yes, all looks good. And we have to remember that the certificate template is going to be subordinate certification authority. Now, this is very important. Let me very quickly bring up the documentation as well. This is our documentation which is saying, which is telling us how we can get our CSR signed by our on-premise CA in case of BYO CA scenario. And all the steps are the same that I have followed up till now. It says that open the REQ file that you have downloaded, and do a control C of the content. That is what I did. Then it says that browse on a device which is hosting the web CA enrollment, CA web enrollment page, and then go to this URL. I have done that. Then click on request certificate, go to the advanced option, and then paste what you have copied. And in the certificate template, select the subordinate certification authority. The subordinate certification authority template needs to be published. In my case, it is published, therefore we can see it over here. If it is not published, then from searchserve.msc we will have to publish it. I will show it to you guys very shortly. So over here, coming back over here, I have selected the subordinate certification authority from here. Okay, and so now I'm going to click on submit, and then it gives us an option of downloading the files. Okay, so now I'm going to click on download certificate, and just when I click on download certificate, it downloads the certnew.cer. Let's take a look over what the CER is. So if I double click and open it, this is actually the signed CER. You can think of it that way. So we downloaded the unsigned CER from the Intune portal. We uploaded it to the UI utility over here. The CA signed it, and now we are able to download the signed version of the CSR, if you would call it. This is nothing but a certificate which has been issued by the on-premise CA, and it has been issued to the BYOCA, which is there in the Cloud PKI. If you go into the details, you can take a look over the thumbprint as well over here. Okay, so far so good. We have downloaded the CSR has now been signed. Now we have an option of downloading the certificate chain as well. So if I just click on this, it downloads the certificate chain. Let's take a look over the download folder. This is a P7B file. Let's double click and open this. And this chain actually contains both the certificates. It contains the certificate issued by the root to the root, and it contains the certificate issued by the root to the issuing, which is downloaded in the previous step as well. So over here, the CER is same as this one. So if I double click and open this, if you go into the details, if you look at the thumbprint, it is the same one starting with 566. So long story short, what I'm trying to say is we have to download, what we have done is we have downloaded the CSR from the Intune portal, which was unsigned. We got it signed by the certification authority. And then from this UI, we downloaded two files. The first one was the signed CSR, or a certificate which is issued by the on-premise CA to the issuing CA in the cloud, or BYOCA, and second is the entire chain. Now once this is done, we have to upload these two to the Intune portal. So now let's go to the Intune portal and upload these two. So as you can see, this still says that signing is required, has not been it still says that it has not been signed. So I'm just going to click on this, and it says upload signed certificate. This is where I am going to upload the two files. So there are two files that needs to be uploaded. The first file, it says over here, download the CSR for the issuing CA. The CSR must be signed by your private certification authority. We have done that. Download the entire chain as well, and that is why we downloaded both the files. So over here we have to upload the signed CSR. So I'm going to click on browse, and over here I'm going to select the .cer, which is the signed CSR, which is nothing but a certificate issued by the on-premise CA to the BYOCA. I just click on open, all good. And now over here I have to upload the chain, and it says that the format should be P7B. So I'm just going to click on browse files, and then over here it shows the P7B file in the download section. So I'm just going to click on open, and then it shows me the name of the file. I just have to click on save, and there you go. All right, so now my issuing CA is created for BYOCA scenario. Just changed its name a little for better understanding. So over here you can see that there are two issuing CAs. The first one has external root, and the second one has root CA, which is there in Intune. Hence first one is for BYOCA kind of a scenario. So if I click on this, now it is activated. If I go into the properties, I can see all its properties, right? The CA type is issuing CA, EKUs are there. The validity period is not configurable, and it's not showing the validity period because it depends upon the validity period of the CA on-prem. And then rest of the information, and then over here you have the SCEP URI as well. Okay, so far so good. So now let's go ahead and create our SCEP profiles. So let me just duplicate this tab. So I'm going to go to devices, and then again the same drill again. Let's quickly create a SCEP profile. I have already created the trusted root profiles because we already know it's very simple. We just have to upload the .cer. I'm going to directly create the SCEP profile now. So this is going to be Windows 10 and later, templates, and then SCEP certificate, create. Let's call this EAI latest BYOCA SCEP. Now we have already seen this certificate type is going to be user subject name format. Let's leave it at this, and the subject alternative name, let's use UPN with this as the value, and the certificate validity period, I'm fine with 1 year. KSP, let's do enroll to software KSP. Key size usage, let's do both. Key size bits, let's do 4096. Hash algorithm, let's do both. Now this is important. Root CA certificate, we have to link this with the right root CA certificate. So this is going to be the root, not the issuing CA, but the root CA certificate, which in my case is CPKI trusted new. Just selecting that over here. You have to select the EKUs over here. So let's do client authentication. We cannot do any purpose, just a reminder. And over here, we have to enter the SCEP URI. So I'm going to fetch the SCEP URI from here, and this is ending with 813. Just copied it from here and just entering the SCEP URI over here. So far so good. Let's do a next, next, and we just have to assign this. So let's assign it to a group. The name of my group is CPKI. I'm just going to select this, select next, next. And before I click on create, let's quickly go to the device. So this is my device. Let's make sure that the root and the issuing has come down. Then we will assign this profile, and then we will launch the syncml tool. And I want to show you guys everything that is happening in the device. So let me just first show you guys the name of the device. So name of the device is Cloud PKI. So this is our device. And if I check the deployed certificates for this, let's go to device configurations. And over here, you see that the issuing and the trusted root certificates both have come down. So now it's time for us to deploy the SCEP certificate as well. So before I assign the SCEP profile, let's quickly go to the device. And over here, you can see that the sync ML viewer tool is running. Let's wait for this tool to finish running, and then we are going to initiate us. Then we are going to assign the profile and then initiate a sync. All right, so the MDM sync just completed running. So let me just go back to the portal and then quickly assign this profile. Okay, there you go, EI latest SCEP. So I'm just going to go over here, clear stream, and then initiate a MDM sync again. Now the expectation is that the SCEP profile should come down, and then we will see we will see which URL is actually coming down. Is the URL that we have provided in the SCEP profile is the URL that comes down, or something else comes down? And if that is the case, then we will track the logs as well. So let's just give it a couple of minutes, and then we will come back over here and see. Okay, so the SyncML session just completed running. So let's just go through this and see what exactly happened. So I'm just going to scroll down because initially we see all the junk value, and then I am going to look for the information that I'm looking for, something related to the SCEP URL. So, so until now, I mean, these are all information not related to us. This is something related to the AAD token user. So what the SyncML tool does is it is going to capture all the communication between the device and the service side, Intune service side. It is not just limited to the policy that we are tracking, right? There is so much of thing that is going on between the two. So we have to understand what is relevant and ignore the ones that are not relevant to us. So I'm just going to ignore the ones that are not relevant and keep on looking. And yeah, there you go. This seems relevant. So over here you can see that the device has received the SCEP server URL, and this is the URL that the device has received. So let me copy this in a notepad and show you guys whether this matches with let me just open a new notepad file. So this is the URL that the device has received. And if we take a look over the properties, this is the URL that was sent that we had in the profile. So the URL that we had in the profile was HTTPS and then that was Cloud PKI FQDN ending with 90813. And what has the device received? The device has received a URL ending with 90813. The starting is a little different. I will explain this later on. But over here, you can see that the device has received the server URL. Okay. From the Intune profile, and along with the server URL, if you guys recall the flow, the device is going to receive the challenge as well, right? Which the Intune service reaches out to the SCEP service in the Cloud PKI, it gets this challenge, and then that challenge is sent to the device along with the SCEP profile. So this is the encoded challenge that the device has received, and this is the SCEP URI that the device has received. Along with that, the EKUs have been received as well. This is the EKU that the device has received. This corresponds to client authentication. And then the key usage also the device has received. This is the value of key usage. And then the subject name is going to be the name of the user, which is PM at the rate everythingaboutintune.com. So far so good. And then the key protection, the retry delay, and all the information, that retry count, all the information that was there is present over here. And the key length, which is 4096, the hash algorithm is SHA-1 and SHA-2. So you can see that whatever we had in the SCEP profile matches with what the device has received over here. And then the thumbprint of the certificate, this is the thumbprint of the this is not the thumbprint of the SCEP certificate. This is the thumbprint of the certificate that the device has received along with the along with all the other information. And then you can see the subject alternative name as well, and then the validity period in months. We see the validity period in months, and what else? Uh, 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 that is pretty much it. So by this information, whatever I am highlighting right now, we can conclude that the device has received the SCEP profile and everything matches. Okay, so far so good. After the device receives the SCEP profile, what happens next? There are a lot of things that are going to happen next. For that, we need to switch over to the event viewer. So let's go to application and services logs, and let's just take a look over the event viewer logs. So we are going to go to device management, enterprise diagnostic provider, and then admin. The first log, if you guys remember the PPT, the first log that we are looking for is the device generating the CSR, and that is logged with the event ID 306. So now let's look for an event ID with 306, and there you go. I think I just scrolled by it. Yeah, there you go. The device over here is generating the CSR, and this is the event ID 306. Okay, so the device has generated the CSR. We have seen the event ID 306. What next? After this, the device is going to go to the URL that it had received and do a get CA cert, get CA caps, and all of that. So this is the URL, and this is the event ID ending with 36. So now let's see that after 306, whether we see 36 or not. We surely do. Here you see the event ID 36, and over here it is sending the SCEP request to the NDES URL. And what is the URL? This is the URL, and this is the same URL that we saw that the device received in the SCEP profile. So, so you see that both the URLs over here match. This is the URL to which the device is reaching out, and this is the URL that the device has received. Okay, so far so good. The device has reached out to the SCEP URL, and it has done the get CA cert, get CA caps, and it has then sent the CSR over here. Now, after the device sends the CSR, what is going to happen next? Now, the SCEP service is going to validate the request, and post validation it's going to issue the certificate. Now we cannot see the logs for these two steps because it's happening at the service side. And then what happens is, then the certificate is delivered to the device via MDM channel that is logged with the event ID 309. So let's see whether we see any log with the event ID 309 or not. And there you go. We see the event ID 309 as well. And over here, you can see the thumbprint of the certificate also, which the device has downloaded. This thumbprint is going to match with the other thumbprints that we have seen, and then the device is going to install this certificate. So over here, you see that the thumbprint of the certificate is ending with 6010. So now if I go into the MMC, you can see that, so this is the old certificate. You can just ignore this. It has a previous date. This is the latest certificate. It has been issued by, see over here, it says that the issuing is BYOCA, which is the CA in the cloud, and it has been issued to the user. If I double click on this, go to the details, and if I check the thumbprint, it is starting with 03E6010. So which matches with 03E6010 over here. So now we can see the thumbprint of the certificate as well, and then the device is going to install this certificate. So this is pretty much in line with what we have seen earlier. The device reaches out, so the flow is pretty much simple. The device is first receiving the profile, the SCEP profile, which can be tracked in the syncml logs, and then over there we can see the URL as well, the SCEP URI. The device is reaching out to that URI, doing the get CA cert, get CA caps, and then the device is generating the CSR, sending the CSR. After that, the verification of the CSR and all of that is not logged at the device end, and then the device is receiving back the certificate and downloading and installing it, and then we are able to see it in the MMC. So far so good. Now, one more thing that I wanted to tell you guys is, how is the device doing the get CA cert, get CA caps, and is there a way to do that manually? The answer is yes. So let me just copy this and then go to any browser. Okay, so I am at the browser and I am going to go to the same URL that the device has received as per the event via logs or as per the syncml trace, which is this. And I am just going to append something at the end, which is question mark operation is equal to get CA caps, and this is going to tell me the, this is not case sensitive, so this is going to tell me the capabilities of the CA. And over here you can say, if I do a get CA caps against, so I am doing a get CA caps against the NDES URI, and I am getting a response over here. Similarly, instead of get CA caps, I can do a get CA cert also. So instead of get CA caps, let me do a get CA CERT, and then this is going to download the certificates. So I even have an option of opening the certificate. So let me just right click on this and rename these to P7B format. Now I can just double click and open this certificate, and this opens in my cert user store. If I expand this, this actually contains a bag of certificates, and it contains three certificates. First is the certificate issued by the root to the root. That is a trusted root certificate. Second is also a trusted root certificate, which is issued by the root to the issuing. And third is the RA certificate. So this RA certificate is going to be used by the device to encrypt the CSR when it is sending the CSR to the SCEP service. And it's going to use the public keys to encrypt the CSR, and the SCEP service is going to use the private keys of this certificate to decrypt it. So again, this is what the response of get CA cert is. It is a bag of certificate which involves the RA certificate as well as the root and the issuing. When we had the on-premise NDES also, over there also, when you did a get CA cert, then also you would get two RA certificates. Over there we had two RA certificates. Now we have only one RA certificate, but that is also coming. And if you check at the details of the RA cert, you see that it has been issued by the issuing CA, and this is issued to this RA certificate. And you can take a look over the thumbprint and all of that. So the moral of the story is, the device is also doing a get CA cert, get CA caps, which we can also do manually by going to the browser. Now there is one more difference that I wanted to show you guys very quickly, and that is, the difference in the URL. You see, the URL that we provide in the SCEP profile is this, and the URL that the device is receiving is this. So let's compare these two and see if there is any similarity or difference between them or not. The URL is exactly the same, except you see this. This is replaced by fefmsuc02.manage.microsoft.com, and after that everything is the same. So think of this as like a CNAME record. So this is actually pointing to the MSU of where your tenant is located or where your cloud PKI is present. So when you deliver this URL, this variable gets replaced with the relevant MSU, and then that URL gets deployed to the device as a part of the SCEP profile. So, and when the device reaches out to the URL, the device is reaching out to this URL because this is the URL that the device has received to begin with. If I can go to the SyncML again and show you, this is the URL that the device has received, which is FEF-MSUC02, and um, and to this the device is making all the requests. So this is the actual MSU of the device, and this is what we have in the SCEP profile. As I said, think of this as like a CNAME record like we have in our Active Directory, right? So the reason of having this is if we have to redirect traffic to, let's say, A, and later on we have to redirect the traffic to, let's say, B. So instead of having A or B and then replacing it later on, we use a placeholder, if you would call it. So we already know what CNAME is. I'm not going to go into the very details, but think of this like a variable, and this variable is redirecting to the MSU where your cloud PKI instance is present. So um that is the flow that I wanted to show you guys, and that is how you could do a get CSCert and get C caps operations. If you want to do a get CSCert and caps operations, you cannot do it with this URL. You need to know what is your MSU, which you can see by looking at the syncml logs like I showed, or the event via logs. And if you replace it with that, then at the end you have to append operations is equal to get CSCert or get CA caps, and then you can find out, like I just show you guys, what are your CS capabilities and what are the certificates. Okay, so the SCEP certificate is now down in the device, but what do we do with it? We did not deploy the SCEP certificate via Cloud PKI just because it looks cool and it is fancy, right? There has to be some actual usage behind deploying that SCEP certificate. That is what we are going to understand right now. But before we understand how that SCEP certificate can be used for, let's say, Wi-Fi authentication, and what are the other things that we need to cater to, as far as Wi-Fi or VPN authentication is concerned, I wanted to take a moment and explain you guys the concept of chain building and why this is important. So let us say that this is the client certificate. So the client certificate over here is the one that is issued by the Cloud PKI. This is the SCEP certificate. So the client certificate is issued to the username. It could be the UPN, it could be just the username, and it has been issued by the issuing CA. Okay, now let's say that this is a server to which this client certificate has to be presented in order to facilitate the authentication. Now this server does not know this certificate, right? How will this server trust this certificate? This server has no reason to trust this certificate right now. The only way by which this server is going to trust this certificate is if the chain of this certificate is present in this server's certificate store. What I mean by that is, this is the client certificate which has been issued by the issuing CA. Now, if anybody asks you what is the chain of this issuing CA, so the chain of this issuing CA would be the certificate which is issued to the issuing CA by the root CA, and the certificate which is issued to the root CA by the root CA. So this is, in a way, you can say, kind of a hierarchy. First, there is a root certificate which is issued by the root to the root. Then there is an intermediate or an issuing certificate which is issued by the root to the issuing CA. And then there is the leaf or the client certificate which is issued by the issuing CA to the user. Now, as I said, this client certificate will be presented to a VPN or a Wi-Fi endpoint for authentication. Now, this Wi-Fi endpoint is only going to trust this certificate if the chain of the issuer, in this case, the issuer is the issuing CA. If the chain of this issuing is already present with this VPN or Wi-Fi server. So what I mean by that is I am at the local computer MMC store. So over here, if I go into the trusted root certification authority and certificates, these are all the trusted root certificates that are present in my device. So my device is going to trust any certificate, any SSL certificate or any kind of certificate which is issued by DigiCert only because the root certificate of the DigiCert is present in the trusted root store of this device. So if I double click on this certificate, you see that this is the root certificate for DigiCert, which is issued by the DigiCert CA and issued to the DigiCert CA. So just because this root certificate is already present in the trusted store of the device, my device is now going to trust any other leaf certificate which is issued by either this DigiCert root CA or the DigiCert issuing CA. All right, so that is the point that I'm trying to make over here for the Wi-Fi or VPN endpoint to trust this client authentication certificate. The Wi-Fi or VPN endpoint needs to have the root certificate and the issuing certificate of the issuer over here. This is something very important and we have to always keep this in mind. Now, this concept of the endpoint having the entire chain in order to trust the entity certificate. This is not just applicable for, let's say, VPN or Wi-Fi authentication. It is also applicable for, let's say, a web-based authentication. Like for example, let's look at a website called facebook.com. So when we go to facebook.com, this is a HTTPS connection, which means that there is a SSL certificate which is binded over here. So if I look at connections and if I look at the certificate, you see that, and in the details, you see that this has a certificate which is issued by DigiCert High Assurance EV Root CA. And my device has the DigiCert High Assurance EV Root CA already installed over here. That is why my device is trusting this website. Otherwise, you would have seen that in many, when we go to, if you would have seen somebody going to some shady website, you would see that it gives an error message saying that this website is not trusted and go at your own risk or something like that, right? So that is the point I'm trying to make. For any device, any entity, may that be a VPN server, Wi-Fi server, or even my device, for it to trust any certificate, may that be the SCEP certificate, may that be the SSL certificate which is binded to any website that my device is going to. For this entity to trust it, it needs to have the entire chain of the certificate that it is looking at. Like in this case, my device is looking at a SSL certificate which is binded to facebook.com. So my device needs to have the entire chain related to the certificate that is binded to the website for facebook.com, the SSL one. Similarly, for this entity, if this is a Wi-Fi or VPN server, for it to trust a client certificate which is being presented to it, it needs to trust the entire chain for this certificate, and the entire chain of this certificate is, as I said, the root, which is root CA certificate issued to the root itself, and the root CA certificate issued to the issuing. So everything, I mean the entire chain of this certificate is something that this device needs to have. All right, so this is a concept that we are going to keep in mind. And now let's just talk about how the certificate based authentication is going to happen. Now I am going to explain two scenarios of certificate based authentication. The first scenario is going to be this one, wherein the root and the issuing both are present in the cloud, in cloud PKI. And the second scenario that I will explain is going to be BYOCA scenario, wherein the issuing is present in the cloud, but the root is present in the on-prem, and the issuing in the cloud is anchored with the root in the on-prem. All right. So then let's take a look over cert-based authentication for Microsoft Managed CA. So these are the two entities that I have. On the left hand side over here is the device, and on the right hand side over here is the Wi-Fi access point. The device has received, let's say, a SCEP certificate from Cloud PKI, and the device has to present that SCEP certificate to this Wi-Fi endpoint and undergo the authentication. Now, as I said, the device already has the SCEP certificate. What will the SCEP certificate look like? The SCEP certificate will look like this, right? Like the SCEP certificate is issued to the user, and the SCEP certificate is issued by the cloud PKI issuing CA. So over here in the cloud, there are two CAs that are present, right? First is this is the root CA, and this is the issuing CA. The issuing CA has the SCEP URL. This it has the SCEP URL over here, like we have already seen, and this issuing CA is linked to the root CA in the cloud, right? So this is the CPKI infrastructure. Okay, so I hope that we have understood this until now. Now for this, so this is the device, and this device contains this SCEP certificate. Now we already know that for a device to have receive a SCEP certificate, it needs to have the entire chain, right? Only then the device is going to trust that SCEP certificate. That is exactly what we discussed in the previous slide. So this device right now does not know what the certificate is, right? Because it does not trust the cloud PKI issuing CA. It does not know what cloud PKI issuing CA is, right? So it is only going to trust this cloud PKI issuing CA certificate if it has the entire chain of this certificate. So this is the, as I said, this is the issuing CA and this is the root CA, right? So this device needs to have the entire chain for this certificate. What is going to be the entire chain for this certificate? The entire chain is going to be first the certificate which is issued to the issuing CA, which is this, and issued by the root, which is this. And the second is going to be the certificate issued to the root, that is this one, and issued by the root, that is this one itself, which is the self-signed certificate, right? So there are two certificates. Let me quickly go to the previous section. So over here, the same method, the same concept that we had over here. For the client certificate to work, it needs to have the entire chain. The chain first is going to be the certificate issued to the issuing CA by the root, and the second, it's also going to contain the certificate issued to the root by the root, which is the self-signed certificate. So that is what I'm talking over right now. So this device will have this and this, and only after that it is going to get the SCEP certificate over here. All right. Now on the right hand side, there is this Wi-Fi. Now this Wi-Fi, whenever you connect to Wi-Fi, just like when you are connecting to a website, when we were connecting to facebook.com, the connection to facebook.com was encrypted via HTTPS, right? Which means that there was a web SSL certificate which was binded to the website. Similarly, whenever you connect with, let's say, this Wi-Fi or VPN endpoint, it is all to make that connection secure. It is also going to have a SSL certificate, which in this case is a certificate issued to this Wi-Fi access point and a certificate issued by the root CA. Now, the difference that I want to point out over here is Cloud PKI is issuing certificates only to the on-premise, only to the devices which are enrolled to Intune, which in this case is this end device. But Cloud PKI is not going to issue any certificates to Wi-Fi or VPN endpoint, because as of now, we don't have the ability to issue certificates to devices which from Cloud PKI which are not Intune managed, meaning this Wi-Fi endpoint needs a SSL certificate which is issued by the root CA and which is issued to the Wi-Fi access point. But this Cloud PKI does not have this certificate. So where will this Wi-Fi endpoint get this certificate from? This Wi-Fi endpoint has got this certificate from a root CA which is present on-prem. So this is the cloud. The cloud contains a root CA and a issuing CA, and this is my on-prem. The on-prem also contains a CA right now, but this CA and this CA, they don't talk with each other. Because if they were talking with each other, then that would be a scenario of BYOCA, right? Wherein you have the issuing in the cloud and the root anchored in the on-prem. Right now, we are not talking about that concept. Right now, we are talking about a concept wherein both the root and issuing are present in the cloud. But that does not mean you cannot have a separate root in your on-prem. You can always have a separate root in your on-prem. And in this case, you need to have a separate root in your on-prem. Because if you don't have a separate root in your on-prem, then where will you get this SSL certificate from? Because right now, Cloud PKI, even if it wants to, it cannot issue a SSL certificate to anybody because it can only issue certificates to devices that are enrolled to Intune, and a Wi-Fi endpoint cannot be enrolled to Intune. So what I'm trying to say over here is the Cloud PKI issuing CA is this one, the Cloud PKI root CA is this one, and the root CA that you see over here is this one. Okay, so this root CA signifies the root certification authority which is present in our on-premise infrastructure, and this root CA, which is this, is not talking with the Cloud PKI root CA, which is this. Both are mutually exclusive. Okay, so again, taking a step back, this is the Wi-Fi endpoint. The Wi-Fi endpoint has a SSL certificate. The SSL certificate is issued to the Wi-Fi access point and issued by the root CA present in the on-prem. Again, why will the Wi-Fi access point trust this SSL certificate? It will not trust this certificate until and unless it has the chain for this root CA, meaning this Wi-Fi access point is also going to have a certificate which is issued by this root and issued to this root, which is the on-prem one. So there will be a so this CA is going to issue in this case two certificates. First is the SSL certificate, which we are seeing over here. And obviously, when you install the root certificate, it has a self-signed certificate as well, right? Which is issued by the root to the root, right? Just like this root has a root certificate issued by the root to the root. Similarly, this root CA is also going to have a root certificate which is issued by the root to the root. So the point that I'm trying to make and the point that I'm trying to clarify over here is this SSL certificate can only be trusted by this Wi-Fi endpoint if this Wi-Fi endpoint has the entire chain of the issuer of this certificate. So the issuer of this certificate is root CA. So this Wi-Fi endpoint needs to have the entire chain for root CA as well, which is the certificate issued by the root, issued to the root. So this is the setup. On the left hand side, we have a device. The device has a SCEP certificate which is delivered to it by Cloud PKI. The Cloud PKI has the root and the issuing. Both are there in cloud. They are not talking with the on-prem. We are talking about the Microsoft managed setup. And for device to trust this SCEP certificate, the leaf certificate, it needs to have the entire root of this issuing, which is going to be the certificate issued by the cloud root to the cloud issuing and the certificate issued by the cloud root to the cloud root itself. On the right hand side, we have the VPN access point. The VPN access point has a SSL certificate. The SSL certificate is issued by the on-premise root to the Wi-Fi endpoint. And for this Wi-Fi access point to trust this SSL certificate, it needs to have the entire chain of this root, which is going to be a certificate issued by the on-prem root to the on-prem root. This is the setup. Now let's see what is going to happen. I hope we have understood the setup right now. This is a very basic setup. I tried to repeat it as many times as I could to clarify. Now, the way this is going to work is first the device is going, if the device needs to connect to Wi-Fi, what happens is, the three-way handshake and all of that is going to happen. I'm going to cut short all of that, and I'm just going to talk from uh, Intune perspective over here as much as I can. So the device is first now going to connect to the Wi-Fi SID. It's going to make a request to connect to the Wi-Fi SID that is being broadcasted. So it will send a hello message. The Wi-Fi will respond to it, and when the Wi-Fi is responding to it, now the communication needs to be encrypted. So when the Wi-Fi is going to respond to this device, it is going to send this SSL certificate, so that the device does not have this SSL certificate, right? But the device needs to use this SSL certificate in order to communicate with this Wi-Fi. Just like as I said, like I am trying to connect to Facebook.com. I do not have the certificate of Facebook.com, but when I'm reaching out to Facebook.com, Facebook.com is providing me the certificate. It is providing me this SSL certificate, right? Which is encrypting the communication between me and Facebook.com, right? Similarly, this Wi-Fi access point is going to provide this SSL certificate to the device, so that the device can use this SSL certificate and encrypt the communication happening between the Wi-Fi endpoint and this device, so that only they know what they're talking about. Now, when this device gets this Wi-Fi access point, when this device gets this root certificate, how will this device trust this certificate? The device is not, so the device has been presented by just a certificate from the Wi-Fi access point. Why will I trust it? I am not going to trust it, right? I am only going to trust it if I already have the entire chain of the root. I have the entire chain of this root which is there in the cloud, but I don't have the entire chain of this root, because this root is different. This root is the on-premise root, which means that the device needs to have this root certificate as well. So this root certificate needs to be beforehand deployed to the device. How will we deploy this root certificate to the device? The similar way we deployed this root and this root to the device. And how is it? Just by creating a trusted certificate profile in the Intune portal. That is very easy, right? So when you go into the Intune portal, you have an option of deploying a trusted root certificate profile. So when you are deploying that, when you're making that trusted root certificate profile, you have an option of deploying this root, deploying this root, as well as deploying this route. Okay, so now again, let's recap. The device reached out to this Wi-Fi access point. The Wi-Fi access point responded to it with a SSL certificate. This SSL certificate has been issued by a root on-prem. So my device on the left-hand side is only going to trust this SSL certificate if it has the entire chain for this SSL certificate, and the entire chain for this SSL certificate is going to include this certificate, right? Which is what is sent over here on the left hand side, which is a certificate issued by the on-premise root and issued to the on-premise root. Okay. Okay, so I just cleared the diagram. Now in the next step, what is going to happen is that the device is going to present this certificate. This is the same certificate as this one. So the device is now going to present the user certificate to the Wi-Fi endpoint. So this is the certificate that is actually going to be used for authentication. So if this certificate is correct, then Wi-Fi will allow the device to connect to it. Otherwise, it will not. The Wi-Fi access point. So this is the actual SCEP certificate, that client authentication SCEP certificate that the device is presenting to the Wi-Fi. Now, um, is the Wi-Fi going to trust this certificate? Well, the Wi-Fi does not know what the certificate is, right? So the Wi-Fi is first going to see whether it recognizes its issuer or not. So its issuer is Cloud PKI issuing CA. So the Wi-Fi is going to trust this certificate only if it has the chain of the Cloud PKI issuing CA certificate installed in it. So for that to happen, What we have to do is we have to push these two certificate to the Wi-Fi. That is the chain of the cloud PKI issuing CA certificate, which is there in the Intune service in the cloud. That is the certificate issued by the root to the issuing and the certificate issued by the root to the root. And this, as we have already said, this is not same as this, because this is the certificate issued by the root to the root in the on-prem, and this is the certificate issued by the root to the root in the Azure, in the cloud PKI. So for this Wi-Fi to trust this client authentication certificate, this Wi-Fi needs to have the entire chain of this certificate installed in it, meaning meaning these two certificate. Now the challenge here is, how do you push these two certificates to this Wi-Fi? Now, pushing this certificate to the device was very easy. All we had to do was we had to go to the Intune portal and create a trusted certificate profile, and it got delivered to the device. But pushing these two certificates to the Wi-Fi endpoint is not as easy. Now, why is it not as easy? Because this Wi-Fi endpoint is not enrolled to Intune. So then how do you deploy these certificates to this Wi-Fi endpoint? Now, we can deploy these two certificates to the Wi-Fi endpoint either by group policy, if we have one, or we will have to do this manually. I mean, we will have to manually export these two certificates, which we already have. We already have the .cer, because that is what we deployed via Intune to these two to this device via trusted certificate profile. So we already have the .cer. Now we will have to log into the Wi-Fi endpoint and then manually install these certificates. But the goal here is, long story short, these two certificates needs to be there in the Wi-Fi endpoint. Only then the Wi-Fi endpoint is going to trust this this SCEP certificate, the client certificate. And this is where it is a little challenging in case of cloud PKI, because these two certificates cannot be deployed via Intune. So we either have to rely on our group policy infrastructure, or we have to rely on installing these two certificates manually. So, and in the next section, we are going to see how is this any different in case of BYOCA kind of a scenario. But I hope that we have understood how certificate-based authentication works when we have to connect to Wi-Fi or VPN, when the root and the issuing both are there in the cloud, and what are the prerequisites from certificate standpoint that the device has to meet, which in this case the device needs to have this chain, as well as the device needs to have this one, device needs to have this and this so that it can install the SCEP certificate, and the device needs to have this, the root one, so that it can actually trust the SSL certificate. Now on the Wi-Fi end, I'm just paraphrasing and summarizing. The Wi-Fi's device is going to have the SSL certificate, because the devices are going to connect to Wi-Fi using the SSL, and the device is going to have the the trusted root certificate for the on-prem installed in it, because only then it will let you, only then this device or this Wi-Fi endpoint will trust the SSL, because that is where this Wi-Fi endpoint is, this Wi-Fi SSL certificate is coming from. And now this Wi-Fi endpoint also needs to have these two certificates, because only after it has these two certificates, that is the chain of the cloud PKI, it is going to trust and it is going to entertain any certificate, which in this case is a SCEP certificate, which is coming from the cloud. Okay, so now let's just keep all of that in mind. And now in the next section, we are going to see how the certificate-based authentication differs in case of bring your own CA kind of a scenario. So again, we have got a device on the left-hand side, which is enrolled to Intune, and on the right-hand side, we have the Wi-Fi endpoint. Now, this is a use case wherein we have Intune over here. In the Intune service, we have created the issuing CA, and over here in the on-premise, we have the root CA, and this issuing CA is linked to the root CA. It is anchored to the root CA over here. Okay, so now let's see what happens next. This device has got a SCEP certificate issued to it by this issuing CA in the Azure. So this is going to look like it is issued to this user and it has been issued by the issuing BYOCA. Okay. Now this device is going to install this SCEP certificate only if it trusts this chain. That is, we already know, right? When we create a SCEP profile, the SCEP certificate is only going to come down if the trusted root and the issuing has already come down. So in this case, this device will get a SCEP certificate only if the chain for the issuer, that is chain for issuing BYOCA, is already there in the device, which means that the certificate which is issued to the issuing by the on-prem root and the certificate which is issued to the root by the root, the self-signed one. These two certificates needs to be there in the device beforehand, and then the device is going to get the SCEP certificate over here. So that is the prerequisite that we have on the left hand side. Now let's see the prerequisite on the right hand side. On the right hand side, this Wi-Fi endpoint needs a SSL certificate so that the devices can communicate with it securely. So this device is going to have a SSL certificate. This certificate is issued to the Wi-Fi endpoint and it will be issued by the root CA. It cannot be issued by the issuing CA, right? Because issuing CA over here in the cloud can only issue certificates to devices which are enrolled to Intune, which was this one. Therefore, this certificate was issued by the issuing CA via the SCEP profile. But this SSL certificate is issued to the Wi-Fi endpoint via the on-premise route. Okay, which is this one. So for this device to trust this on-premise certificate, what is it that this Wi-Fi endpoint needs? It needs the root certificate for this issuer, which is the certificate issued by the root to the root. Okay. So now if you see, this certificate and this certificate are both the same. So when the device reaches out to the Wi-Fi endpoint, the Wi-Fi endpoint is going to provide the SSL certificate. This is the SSL certificate, and this is the root. Now this device already has the entire chain for this root over here, right? Because the chain for the root over here and because the chain of this certificate and the chain of this certificate both are the same. Why? Because both are linked to this on-premise CA. So in this case, for this device to trust this SSL certificate, you don't need to install any other certificate in the chain of this device. And similarly, when this device presents the SCEP certificate to the Wi-Fi endpoint, the Wi-Fi endpoint is going to say, okay, who is the issuer? The issuer is the issuing BYOCA. What is the chain of the issue of this BYOCA? The chain of the issue of the BYOCA is the certificate that is issued to the BYOCA, which is this one, which is the root. So this issuing BYOCA is linked to this root CA. So this is what the root is. This is what the base level or tier 1 is. So hence, in this Wi-Fi device, you don't need to install any other certificate, which means that you are not, like in the previous case, we were dependent on group policy to install any certificate manually. In this case, we are not dependent on group policy and we don't have to install any certificate manually on the Wi-Fi endpoint. So this is one of, so now let's say tomorrow we have to make a determination on whether we have to go with BYOCA kind of a scenario which we have over here, or whether we are going to go with a scenario that we saw in the previous section, which is both the cloud, both the issuing and the root are there in the cloud. So this is something that we need to keep in mind as far as working of our infrastructure is concerned, because after the certificate is deployed, this scenario is only going to work if you have manually installed these two certificates on this device, and if you have pushed these three certificates as a trusted root certificate profile to the device that is enrolled to Intune. However, in BYOCA kind of a scenario, you don't need to explicitly install any other certificate on the Wi-Fi endpoint manually or via group policy, because everything is leading back to the same root tier 1, because both of them are talking with each other, because this issuing CA is anchored to this root. Therefore, this device is going to trust this issuer certificate or the SCEP certificate. So that is pretty much it, guys. I hope that in this tutorial we were able to understand what certificates are, why do we need it, what is Cloud PKI, how is it different from the on-premise, the flow of the certificate that is happening at the background, the logs at each and every step that we should check if the certificate deployment is failing, the various ways of of Cloud PKI infrastructure, like the Microsoft managed one or the BYOCA kind of a scenario, the auditing, the reporting, as well as I hope we enjoyed the demo, as well as we understood after the SCEP certificate is deployed, what are the things that we must keep in mind so that the SCEP certificate can actually work out during our authentication. The prerequisite from the device end, that is the root certificates that needs to be installed, and the prerequisites from the Wi-Fi or the VPN endpoint, that is the certificates that are needed to be installed over there so that the Wi-Fi or the VPN endpoint actually trust the SCEP certificate that is issued to the device via Cloud PKI. So I hope this has been informative for you. I would like to thank you for viewing. This is your friend Saurabh Sarkar signing off.